Hello everyone, my name is Sayak. I am one of the organizers of Tensorflow User Group Kolkata, and I wholeheartedly welcome you all to Tensorflow uh, TFUG India Summit. Sorry for the little fumbling there. Uh, so, what's TFUG India Summit all about? Well, it's an online conference on machine learning and TensorFlow, which will be happening for the next 3 days, and we have got an amazing line of speakers waiting for you to sort of witness over. So, without any further ado, I'll hand it off to Siddhant to do the welcome note, and we will take it from there.
Hello everyone, how are you doing? Let me just quickly share my screen. Perfect. I hope my screen is visible. Yes, I could see it. Awesome. Um, so before I begin, allow me to take a moment to talk about the current COVID-19 pandemic, which has caused extreme amount of panic and suffering to the entire world. The world is experiencing things that it has never seen before. We have been in the lockdown. Now things have been like a bit better. We are seeing unlock in at least in India. But I would like to take a moment to tell you, like, we are all in this together. This too shall pass. There's a long battle going out there. We are not we have not won the battle yet. So till then, stay safe, stay healthy, and stay indoors. With this, let me welcome you all to TFUG India Summit. My name is Siddhant, and I work as program coordinator with developer relations team at Google in India. A quick introduction about myself, like my journey in education, my work, and then working with communities. So I did my graduation in computer science engineering from University of Petroleum and Energy Studies, Dehradun. Started a campus company called Digital Vision Studios. Didn't work out well. Joined IBM immediately after my graduation. Worked there for a year and a half. Then joined Be Ahead. Worked there for like 2 years, and then I joined Google like 1.5 years back. Uh, my engagement with communities has been like since I will say rather 2013, where I used to like just attend meetups of GDG New Delhi. But then the actual contributions to the community started in 2014. That since then I've been like associated with communities like in like personal capacity. I became Google Student Ambassador from my university. Went on to volunteer with GDG New Delhi, and then I started off GDG Cloud New Delhi last year in 2018. I also volunteer with Head Start Network Foundation. It's a group of volunteers. It's India's only and the largest grassroots level organization working with startups and early stage entrepreneurs. Also have been an Intel software innovator and Atal mentor of change. So with this 5+ years of industry experience, I believe, like you would have guessed, my areas of interest have been mostly into technology, community building, design thinking, ed tech space, building for next billion users, startup ecosystem, and public speaking. Feel free to connect me on my Twitter handle. Like that's my Twitter handle. Feel free to connect with me. Let me talk about what we do at Google in India. We enable and empower the vibrant Indian developer ecosystem to build impactful solutions using Google technologies that can change the lives of the next billion users. That's what we do. And how we do it, we basically engage in few community programs, and these are the programs that we engage with. Let me take a quick 1 minute and talk about each of these programs if you are like for the first time hearing about these programs. If you have ever heard of GDG, GDG is Google Developer Groups, basically like group of organizers, developers, a community-led group who are interested in Google's developer technologies. These groups like they conduct in-person meetups, they do host talks and stuff. We have 51 GDG communities in India. Uh, Next up is GDE program, which is like very close to my heart. I'm taking care of GDE program in India. It's a global network of highly experienced technology influencers. They support developers, they support companies, communities globally. In India, we have 55 GDEs in various technologies like machine learning. They are in cloud, they are in Flutter, they are in web, they are in Angular, like Android, like all the bunch of technologies you can think of, Firebase, they are there. And these are independent volunteers. They do not work at Google nor for Google in any capacity. You will be hearing a few of the GDEs here in this TFUG India Summit. Coming up next is GFSA, Google for Startups Accelerator Program. It's a program that helps startups build and scale great products. We all know the best of Google, that's its people, its network, and its thought leadership and technology. And that's where we bring this best of Google to these startups, connecting them to our network as well. Uh, we have seen like amazing startups coming out of these accelerator program and doing amazing in the industry after they join the accelerator program. If you're a student, you might have heard about this program. If you're an undergrad student, it's called Developer Student Clubs program. I'm again leading this program in India. Developer Student Clubs program basically talks about bridging the gap between theory and practice, encouraging students to solve local problems, uh, come up like share their knowledge in a peer-to-peer learning environment. They build solutions for local businesses and their communities. uh, the numbers, I need to update these numbers, but in India we have more than 250 DSC chapters all across the country in more than like 120 cities. We onboarded the latest batch of DSC just like few days ago. We have 275 DSCs in India. Next is Women Tech Makers program. For all the women out there who are listening to me, this is a program for you which engages over 100,000 women in tech across 190 countries each year. It provides visibility, community, and resources for women in technology. There are 58 Women Tech Makers ambassadors. Why we created this separate program? Just to encourage more women in technology, give a safe space, bring in more visibility for women in tech, help them drive innovation and participation in the industry. And not last but not the least, the TensorFlow user groups. We have 13 TFUGs in India, and they are like across the globe. They are a community of curious, passionate machine learning developers and researchers. They have played an important role in helping developers share their learnings, their knowledge about machine learning, what is happening in latest TensorFlow. Google and TensorFlow team are proud of and grateful for many of these TFUGs around the world, and we are excited to see them grow and become active developer communities. Currently, we have more than 75 TFUGs around the globe on 6 continents with events in more than 15 languages, engage in many creative ways to bring developers together. And that's where we bring this TFUG India Summit by 13 TFUGs in India, putting a show for 4 days with 16 amazing speaker lineup and 20 expert sessions, and of course, 4 community project showcases. I will not hold you back with the amazing speaker lineup that has been organized by this amazing crew of 13 TFUG organizers. But would like to talk about what's in store for you for the next 3 days, like 4 days, today, tomorrow, day after, and then on the 6th. So today we'll be covering the track TensorFlow Core and TensorFlow for Web. Tomorrow it's TensorFlow for mobile. On 5th, we would be talking about TensorFlow for production. And 6th, there will be speakers who will talk about TensorFlow for research. I'm sure you all are excited as I am and would request you to have an amazing time. I'm excited to hear of the speakers. There's an amazing speaker lineup. I'm so pumped up uh, to hear them. So thank you once again for joining for this TFUG India Summit. Have a fantastic summit. All the best to all the speakers. All the best to all the TFUG organizers out there working in the back end to put up this amazing show. If you would like to connect with me, and that's my Twitter handle again, feel free to reach out to me. And with this, I will pass on to Shayok once again.
Thanks, Siddhant. That was a lovely welcome note. So Now's the ultimate showtime, folks. We are extremely excited to bring you Sandeep Gupta to you. Sandeep, Sandeep is a product developer on the TensorFlow team, where he helps drive and develop the roadmap of TensorFlow. I'm sure we all know what TensorFlow is, right? Currently, his focus areas include uh, TensorFlow Enterprise and TensorFlow JS. TensorFlow Enterprise is a development environment for TensorFlow, highly optimized for Google Cloud Platform. And TensorFlow JS, the name sort of speaks for itself, right? So without any further ado, Sandeep, why don't you take it away?
Hello, everyone. Good morning. Hopefully, everyone can see my screen and my slides. Thank you for the introduction, Shayak and Siddhant. I'm Sandeep Gupta. I'm a product manager in the TensorFlow team. And I'm excited to welcome all of you to the TensorFlow User Group India Summit. Last 2 years, I had the pleasure of meeting many of you in person in the TensorFlow India Roadshow events. This year, I'm glad to be able to join you by this live stream. So as Siddharth mentioned, right, it's impossible to not think about what's happening in the world today and how it's affecting our work and our lives. These are uncertain times, and it's becoming clear even in these times that emerging technologies such as machine learning can play an even more important role for the society around us. So it's been comforting to know that we are part of an important infrastructure for the world that has the ability to help others. So as one example, within Google during these times, we have seen how TensorFlow is playing a timely role in supporting Google Meet, which is our video conferencing software. You can see it being used as an education platform in the photo on the bottom middle. TensorFlow helps Google Meet to adapt to changing network bandwidth conditions and enhances picture quality. Since making Meet's advanced features free for all G Suite and G Suite for Education users in March, the daily usage of this platform has grown enormously by about 30 times, with me now hosting more than 3 billion minutes of video meetings every day. So, this is just one example of how TensorFlow is helping us adapt and support new forms of communication and collaboration. TensorFlow and machine learning are making a positive difference in many ways across many domains. And we're also seeing this in the form of increasing developer activity and productivity at an unprecedented level. So TensorFlow now has more than 100 million downloads, with about 12 million downloads just in the last 1 month alone. Tutorials and guides content has been viewed more than 45 million times. And now there are more than 500,000 people enrolled in our courses at Udacity and Coursera. So in this talk, I want to share a little bit about some of the recent updates in TensorFlow. Let me first start by recapping what we launched the last time the TensorFlow global community got together, virtually, that was, at the TensorFlow Dev Summit. So we hosted our third annual Developer Summit in March, and we announced a lot of exciting updates. Building off the momentum of TensorFlow 2.0, we released TensorFlow 2.2. This release focused on speed and performance, helping get great performance out of the box, combined with TensorFlow 2's usability improvements. With this release, more parts of the TensorFlow ecosystem became compatible with TensorFlow 2. And we also focused on stability in the core library. As part of TensorFlow 2.2, we announced several updates for the TensorFlow ecosystem. To better help researchers, we launched performance profilers in TensorBoard, which provide consistent monitoring of model performance. We launched a new TensorFlow model garden. This has best practice reference implementations for many key models across vision, NLP, and structured data. These models are all written using TensorFlow 2, and they achieve great performance and accuracy out of the box. We also updated many add-ons and extensions. So libraries like TF probability, which lets you do probabilistic modeling and machine learning, and TF agents, which is used for reinforcement learning, these now work with TensorFlow 2.x. And also, many new libraries were launched. This includes TF Quantum, which lets researchers at the cutting edge of quantum computing build and explore hybrid quantum classical machine learning algorithms with TensorFlow APIs. We also had exciting updates for deployment on devices and platforms. So for TensorFlow Lite, we introduced best-in-class performance for acceleration that reduces out-of-the-box latency. We added Android Studio integration, so you can automatically generate the Java classes for your TF Lite model with just a few clicks. We also rebuilt the TF Lite converter completely from the ground up, and this now supports more models. It has more intuitive error messaging when converter fails, and also adds support for control flow operations. Finally, we introduced TF Lite Model Maker. This lets developers fine-tune pre-existing models without doing complicated ML. So Khan Leviat will talk more about TensorFlow Lite tomorrow in the mobile track, so be sure to catch that. TensorFlow JS brings the power of TensorFlow and machine learning to the web and to the JavaScript community. We have released new models for face and hand landmark detection and tracking. And for NLP, there is Mobile BERT, and all of these are ready to use for web applications. We also have a new WebAssembly backend for improving the performance of TensorFlow JS on CPU devices. So you definitely don't want to miss the talk by my colleague Jason Mays later today, who will show some amazing applications and demos with TensorFlow JS. And we also shared how using TensorFlow in production got even easier with an exciting launch in partnership between TensorFlow Extended and GCP, which is Google Cloud AI Platform Pipelines. So Cloud AI Platform Pipelines makes it easier to build end-to-end production pipelines using Kubeflow and TensorFlow Extended, conveniently hosted on Google Cloud. There are many more updates in TFX, and these will be covered by Robert Grove on September 5th. After the Dev Summit, we released TensorFlow 2.3 in July. The focus of this release was to make it easier to load and pre-process data and to solve input pipeline bottlenecks. So this is done with two new APIs in TF Data. One is the Service API, which improves training speeds by distributing data loading and pre-processing to a cluster that you can run alongside your training job. And the second is the Snapshot API, which helps you save and reuse your pre-processing outputs to help improve data pipeline efficiency and overall performance. There are also new features in TF Profiler, which allow you to visualize your model's memory usage over time and trace Python function calls in your model, giving you the ability to spot performance bottlenecks. Today, I'd like to share a few details about what to expect in the upcoming TensorFlow 2.4 release. This release's major focus will be on distributed training. It will make multi-worker synchronous training with mirror strategy more robust against deadlocks. There'll also be experimental support for parameter server training in tf.keras, a feature that many users have been asking for. Plus, there are more fixes and improved documentation for better usability. TensorFlow 2.4 will also add support for CUDA 11, which will support some of NVIDIA's latest GPUs. And lastly, there is TF NumPy, which is a new experimental package which will add support for accelerating some NumPy ops using TensorFlow runtime, and also allow you to use TensorFlow APIs with NumPy, so you can use things like gradients, compilation, vectorization, linear algebra, all in your NumPy code. But these releases and new features is only one part of what I wanted to talk about. The main strength of TensorFlow and the big reason why you all love and use TensorFlow is its comprehensive ecosystem. It's made up of a vast number of libraries and extensions to help you accomplish your end-to-end ML goals, whether it's to do cutting-edge research or to apply ML in the real world. There's a tool for everyone and every need, and more are being added constantly. If you're a researcher, The ecosystem gives you the control and flexibility for experimenting and pushing the boundaries of what's possible. For applied ML researchers or data scientists, you get the tools that help your models have real world impact by scaling them to production. And then there are libraries in the ecosystem that can help create better AI experience for your users, no matter where they are, whether on mobile devices or in web applications or in IoT devices. So all of this is underscored by what you all, the community, bring to the ecosystem and our common goal of building AI responsibly. So we'll hear a lot more about these first three topics in more depth in other sessions in this summit. Let me share a little bit more about what we are doing in the areas of responsible AI and some of our community efforts. So we at Google are committed to the responsible development of AI, aligned with Google's AI principles. The responsible AI is a set of principles and practices that guide developers in building AI for everyone and making sure that we keep these in mind when we build an AI system. So it touches upon topics like fairness and the issue of bias in AI, of interpretability, being able to explain and reproduce the results of an AI system, privacy, which deals with handling sensitive user data with the protection that it deserves, and security, making sure that data, models, and AI systems are secure. So typical ML workflow has several stages, and responsible AI must be incorporated into all of them. So to do this, you can ask some key questions to ensure that your AI system is inclusive and secure. For example, who is my system for? Or are there any privacy considerations when I'm collecting my data? So these types of questions are important because fairness and privacy concerns are experienced differently in different applications. And so tackling these issues is not a one size fits all. There are many, many tools and resources to help. So for example, TensorFlow Privacy is a library for training your models with differential privacy guarantees. However, sometimes training with privacy can be expensive. So this year we have expanded TensorFlow Privacy to address this problem and be able to tell you how much privacy vulnerability your model has without having to retrain your model. So we added a new module that allows you to test the privacy properties of your model. Here's how this works. So we use the model to predict outcomes on examples that either were part of the training set or not. We then try to distinguish between the two sets. So if the model has really memorized its training set, it will behave differently on the examples it has seen before. And this constitutes a privacy risk. So we output metrics such as area under the curve or attacker advantage to quantitatively measure the amount of memorization that's happening. We also slice the data set to zoom in on subsets of data that looks at misclassified examples or examples that belong to certain classes. So this allows us to pinpoint specific areas of improvement. For example, look at dataset imbalances. We're also collaborating with many educational institutions, such as Princeton University and National University of Singapore, to expand our attack suite. So in these coming months, you will see more attacks added to privacy. By running them, you will have a more complete idea of your model's privacy performance. So to help accelerate work in responsible AI and make things easier for developers, we launched the Responsible AI with TensorFlow Toolkit in June. This packages all of the responsible AI principles, tools, and resources in the TF ecosystem into a single destination on tensorflow.org, and it's a great starting point for you to use these tools for your ML workflow. So finally, I'm going to talk about the most important part of what we are building, and that's the community. And I want to begin by thanking first all of you, your feedback, your contributions, what you are building. This is what makes all of this possible. So thank you very much from behalf of the entire TensorFlow team. At the heart of what we do is bring people together from all around the world to solve AI and ML challenges. These event photos from all around the world illustrate this and make us proud. It's been great to see what our TensorFlow user groups have been up to, from ML challenges, hackathons, show and tells, and content viewing parties. And you can get more involved in these events and community groups. If you've not already done so, I strongly recommend that you join one of the TensorFlow user groups. So as Siddhant mentioned earlier, these grassroots communities, they started organically, and we now have about 73 of them globally, as you can see in this world map. We are especially proud of the awesome work that the India community is doing in these 13 user groups spread across the country. If you find a marker missing where you are located, you can start a user group. So please reach out at this email address shown below, and we can help you get started. To help make TensorFlow more accessible for everyone around the world, we also have an update on translation. So through a new partnership with Git Localize, we have improved the current processing and contribution experience for community translators by adding Jupyter Notebook support to our tooling. So now it's easier than ever for community to contribute translations to our runnable code. Currently, 13 languages have community contributed docs. We have also completed the translation of our guides, tutorials, and other documentations into Japanese, Korean, and simplified Chinese, and more are coming. This is helping improve the product experience for all of our users globally. So in addition to the user groups, another way to get involved with TensorFlow community is with TensorFlow special interest groups, or SIGs. So SIGs exist to help you to lead and build areas of TensorFlow that you care most about. We have 12 SIGs today. SIG Graphics was our latest addition, and more are being added all the time. So most SIGs are led by members of the open source community like you, such as our fantastic machine learning Google developer experts. You can learn more about SIGs and how to participate in the community section of the TensorFlow website. And speaking of Google developer experts, we cannot express our thanks to them enough for what they do and for our communities and technology. They give technical talks, they organize workshops, they run doc sprints, and help in many more ways. And you can see some of the numbers there of just how much impact they have been having. So big thank you to all the GDEs in the audience listening today, and the ones who are helping organize this event today. Another important thing in the TF ecosystem is the TensorFlow certificate program, which we launched this year at the Dev Summit in March. Since launch, we have had more than 1,000 people from 53 countries take and pass the certification exam. This exam is created by the TensorFlow team, and it covers a wide variety of topics across text classification, computer vision, and sequences and prediction. So by passing this foundational certification, you'll be able to share your expertise with the world. You can display your certificate badge on resources like LinkedIn, GitHub, or the TensorFlow certificate network. And we hope that this will be helpful for you to grow your professional career. To widen access to people of diverse backgrounds and experiences, there's also a small number of stipends to help cover the certificate costs. So you can check out tensorflow.org/certificate for more details on all of this. To support AI education, in February, we published a public RFP to support professors who are interested in teaching TensorFlow at their university, with a focus on diversity and outreach. We have funded lots of universities and also a mix of smaller colleges and programs. And now our next steps are to work with these professors and help them launch these courses. And also many of these materials will be made public. So stay tuned for more updates on our blog. So in closing, 5 years ago in 2015, TensorFlow was open sourced. What started as a library for researchers to build and train new machine learning models has since grown into something that we could not have predicted or imagined. You all have helped shape what TensorFlow is. Things that were previously unimaginable are now possible and commonplace. Sophisticated models that took weeks to train now take minutes with the power and usability that is in everyone's reach. So we can't wait to see what the next 5 years will look like, what the future holds, and what you all do with TensorFlow. In addition to the TensorFlow website and the GitHub repo, there are 3 resources here which are a great source of information that you should definitely check out. There's the TensorFlow YouTube channel with a lot of content from events like these and other useful educational resources. There's the TensorFlow blog site where we publish new case studies and new technical articles from the team. TensorFlow's Twitter handle to keep up to date with all the latest that's happening. So use these to stay in touch with us and the team and the entire TensorFlow community. So let's just take a look at some amazing examples that are happening all around with TensorFlow. So I'm going to play this video. Hopefully you can hear the sounds.
There's more extreme rainfall, heavy flooding, forest fires.
The Vatican archive, it will take centuries to be deciphered.
Air pollution is one of the major problems which Delhi people are facing.
Antibiotic resistance is everywhere. If we don't act today, we'll have 10 million deaths per year by 2050.
What I'm excited the most about machine learning is that it enabled us to solve problems that up to 10, 15 years ago we thought unsolvable.
Deep learning is almost perfectly poised for problems in climate science.
We can use machine learning in treatment and management of these respiratory diseases.
Using TensorFlow, we can tackle things we never thought we could tackle. That's like incredible.
We've shown that with a high productivity framework such as TensorFlow, you can get to massive scale and you can get like awesome performance and accomplish your goals.
So thank you so much for listening. I really enjoyed being here with you today, and have a great summit with the rest of the talks today and for the next 3 days. Thank you.
Sandeep, would you like to take a couple of questions that we have received from the participants?
Yes, absolutely.
Yeah, sure. And just so that everyone knows, Sandeep and I had met during TensorFlow Roadshow Bangalore last year. So yeah. The first question is from Abhinav Prakash. He asks when we are getting official TensorFlow forum.
Yeah, we are working on that. I don't think we have a date yet, but we will get back to you on this.
Cool. So the next question is from Raj. Is Trax new DL library supported at Google? What is its future versus TensorFlow?
Yeah, so thank you, Raj. Very good question. So Trax and JAX and a couple of other new research frameworks are certainly being used amongst the research teams in Google. And researchers are sort of constantly coming up with new ways of expressing model creation and trying out new ideas for whatever works best for the type of problem they are trying to solve. These things, there will always be like a funnel and pipeline. And our thinking with TensorFlow is that as these ideas mature and they prove valuable for certain types of things, concepts from that or APIs from that will hopefully feed into TensorFlow. Or we may find other ways of supporting interoperability. And this kind of work is already happening with JAX, for example. So yeah, I mean, I think this thing will keep on evolving. And our goal is to make sure that the right tool works for all the developers with the integrations that make sense.
Cool. I'll keep this question to the final one. So this is a fun question. Vinayak, he's also one of our organizers. He asks, Sandeep, do you still get to code?
Not as much as I would like. Thank you, Vinayak. And actually, my background, my personal background is in the area of classical image analysis and signal processing and image processing. And that whole field has now been completely taken over by machine learning and AI. I'm also the PM for TensorFlow JavaScript. So I did attend the JavaScript bootcamp earlier this year, and I'm trying to pick up some of the TensorFlow JS concepts. But yeah, thank you.
So with that, I think, Sandeep, thank you so much for once again for accepting our invite and for being with us here. It was lovely to hear from you again. I'm personally really excited to try out the new distributed training APIs that are coming from TensorFlow 2.4 release. So yeah, thank you again for joining us.
Thank you, Shayak, and thank you for everything you are doing. Great to be here. Thank you.
Yeah, sure. Thank you. Okay. So now I'll hand over the hosting responsibilities to one of my fellow co-organizers. His name is Ali. He's from TFUG Mumbai. So Ali, why don't you take it from here?
Thank you so much, Sayak. for giving my introduction. Hello, my name is Ali Mustafa, and I'm an organizer at TFUG Mumbai. So the next speaker for us is Lawrence Morani, and I hope every one of you might know him. If you don't, let me give you a short introduction. Lawrence Morani leads AI advocacy at Google, working as a part of Google Research into Machine Learning, Machine Intelligence team. He is the author of programming books, more programming books than he can count, including AI and Machine Learning for Coders, with orally to be published in October 2020. Keep a watch on that. He is also the instructor and creator of YouTube of TensorFlow in practice and TensorFlow data and deployment specializations on Coursera. He runs the YouTube channel of TensorFlow and TensorFlow certificate program for developers at tensorflow.org/certificate. The link is there in the comments. When not working on AI, he's a published sci-fi author, comic book creator, and IMDb listed screenwriter. And I personally remember Lawrence sir from watching his YouTube series, uh, ML0 to Hero, NLP0 to Hero, and so many of them. So thank you so much. I would request Lawrence sir to take over.
Well, hi, Ali. How are you? And thanks for that introduction. I really appreciate it. And I'm really, really happy to be here. Sorry that we can't be here in person. And hopefully very, very soon we'll be able to do events like this in person. So I'm going to get started with my deck. And then hopefully we have some time to answer some questions afterwards. Okay, so as introduced, I'm Lawrence. I lead AI advocacy here at Google. And today what I really want to give you to talk about is an update on TensorFlow Core. Sandeep just gave us a really nice look at the future of TensorFlow, including some of the stuff coming in 2.4. I'm going to be talking about some of the stuff that we've recently released as part of 2.3. So if you consider the TensorFlow ecosystem to kind of look a little bit like this, I always like to think about it as there's an element of TensorFlow that's used for training, and then there are elements of TensorFlow that are used for deployment. And then in between, there's some tools that allow you to kind of bridge these, for example, serializing your model with saved model, and then things like TensorFlow Hub is a really cool repository. But what I'm going to be focusing on today are some of the releases on the left-hand side of the diagram. And I'll start with some of the great things that's happening in TF.data. And TF.data has a complementary technology called TF Datasets. So to talk a little bit about TensorFlow datasets and what TensorFlow datasets is all about is it's really designed to help developers get up and running quickly with using data. And data is the lifeblood of training any kind of machine learning model. So the goal behind datasets is that to provide a bunch of existing datasets and make them accessible with like 1 or 2 lines of code, and then to give a simple and consistent coding model regardless of the data set that you're using that's compatible with other parts of the ecosystem, such as input pipelines. And Sandeep was talking a little bit earlier about them, and there's some very powerful things can be done, particularly if you've got massive data sets that you need to train across multiple models and GPUs and that type of thing. And to have that consistent API for being able to do that, whether you're training locally on your laptop or whether you're training across like a multi-node TPU infrastructure, that type of thing. And there's a catalog of data sets that's in there, and that catalog continues to expand. But just to give an example of how TFDS has been designed to make it a lot easier for you to be able to use your data, here's an example. So the popular learning data set called MNIST, which if you're not familiar with it, is a set of 70,000 handwritten digits between 0 and 9 that you can use to do like basic optical character recognition or handwriting recognition. And you can load the entire data set, the training split of that data set, which is a pre-split set of 60,000 of those 70,000 with a single line of code like this. And then if you want to start building an input pipeline, then you can start doing things like shuffling and batching and prefetching, again, in a single line of code like this. So the goal behind this is just to really reduce the amount of code that you have to write when you're creating a machine learned model. And often we find that like if your set of code is like this big, if you've got like, we found like it can be as much as 80% of your code is just getting the data ready for training your model. A lot of the effort and a lot of the value, of course, that you get is the architecture of the model, but that can be a very small part of your actual code. So in order to accelerate developers and accelerate developer productivity, the goal here is to make it simple, make it very few lines of code, and make it consistent so that if you see an example from somebody that uses one data set, you'll be able to adapt it to your own. Now, some of the types of data that are available in TFDS, it's image data. A couple of data sets that you can see here are horses versus humans, which is a good one for learning, where it's images of horses and humans, and see if you can train a classifier that can recognize the difference. The one at the bottom in the middle is the bean disease, which is a relatively new one. And it's pretty cool that if you've seen the cassava demos, for example, where some farmers in Tanzania have an app that they can just take a photo of a cassava leaf and classify if it's diseased or not, that you can build your own for bean leaves with this data set. And I have a demo of that later. There's also much bigger research ones like diabetic retinopathy, which is this eyeball image on the left. It comes from that, where there are several gigabytes worth of data, and it's cutting edge research data, but it's available for you to use. But it's not just images, there's sound data, there's tabular data, all this kind of thing as well. Lots of folks have been reaching out to me asking, how do I get started with machine learning? What kind of projects can I do? I'm working on my master's and I'd like to build a project. Start taking a look at these data sets and you might find something interesting that you could work on. So a couple of the new things in core TensorFlow and in tf.data that complement this are, there's a new services API and there's a new snapshot API. So let's take a look at them in a little bit more detail. So for the services API, just think about training pipeline management for the moment. So what generally happens if you're using an accelerator like a GPU or a TPU is that that does the training, and then your workhorse CPU machine does the data preparation. So for example, if you've got a large model that you want to train and you want to break it up into batches, typically with time going from left to right, you'll find your CPU is preparing the data, and once the data is prepared, it hands it over to the GPU. The GPU trains the data, and then once that's done, the CPU will start preparing the data again. And you end up with this very inefficient interleaving where the GPU is idle for a lot of the time, the CPU is idle for a lot of the time, and you want to avoid the red boxes, or you want these red boxes to be as small as possible. And as you can see here, while the CPU is preparing, the GPU is idle, and the GPU is pretty expensive. And while the GPU then is training, of course, the CPU is idle. That's a little bit less expensive. But like I said, we want to try to avoid these red boxes. So that's what the service API is all about. And this QR code will take you to a link of some demos and stuff and some documentation for it. But the goal here is to really avoid those kind of performance bottlenecks that I showed on the previous slide. So it's to optimize this CPU to GPU transfer. And the way that it does it is it allows you to create parallel processes, and you can distribute data processing to them. So while your GPU and your TPU are accelerated and they're fast, your CPU, and they're optimized for what they're actually doing, your CPU is a general purpose machine that isn't optimized for what it's doing. It can be quite slow. So if you have this parallel process that you distribute your data pre-processing to, then you can at least minimize the red boxes in the previous diagram that are caused by the CPU. And it will look a little bit like this. So, so if you remember this training pipeline, where, for example, at the early step when the CPU is preparing, that blue box is pretty wide, and the parallel GPU-TPU box as a result is pretty wide. So if you create a service that uses the technology that I just mentioned, and you offload some of the CPU work to that, you'll end up getting it to look a little bit like this. So the amount of preparation time being done by the CPU and the corresponding data service gets minimized, and as a result, the wasted idle time on the GPU also gets minimized. And you could turn your diagram, like I said, to look something like this. And as a result, even though the training on the GPU-TPU stays roughly the same amount of time, the amount of wasted time by that resource ends up being greatly reduced. And in some ways, this diagram can be a little bit misleading because those red boxes on the CPU can also be reduced because you can start pre-preparing the data on the parallel service, and the CPU might end up not being needed after train 2, for example. So the goal here, like we've mentioned, is to reduce your overall training time without optimizing your architecture. And how does this work in code? Well, it's pretty simple. So if you've used TFDS to get your data set, then on your data set, you can apply this option tf.data.experimental.service.distribute, and then you pass it the address of the service that you're using. Now, this is just a little bit of code here. The QR code that I shared earlier on will give you details on how to build one of those services, how to deploy it, and then how to be able to use that within your data set. Again, this QR code will link you to those details. So if you're watching this on YouTube, and even later on, if you're watching this on demand, this QR code will take you to that. So then the other one that's in TF Data, which I find really cool, is this new snapshot API. Now, the goal behind the snapshot API is that if you're doing a lot of processing on your data after you've loaded it, so for example, things like image augmentation, and I'll show what that means in a moment if you're not familiar with it, but if you're getting data from somebody else and you want to do some processing on that, instead of having to repeat that process every time you run your code or train your model, the idea of the snapshot API is that you can load your data, you can do your post-processing on the data, and then you can save that snapshot out. And then that snapshot will be used for subsequent runs of the training. So you don't have to do that pre-processing step again and again and again. And it's not dumb. It's not just like saving it out there and hoping for the best. It actually does get fingerprinted for change management. So then later on, when you want to run, and it will take a look at that snapshot, it will see if that snapshot the same as the previous one that you've used. And if it is, then you can use the snapshotted data. And as a result, in the processing and in the data preparation step for training your models, if you have to do that multiple times, like if you're iterating, if you're trying something new, and but you haven't changed so trying new architectures, but you haven't changed the data and the data processing part, then the idea is that you can save a whole lot of time there by snapshotting the data. And again, I've put this QR code in to take you to details on that, to take you to the documentation on that. So that's on the data design box, so TF Data and how TF Data works with TF data sets, including the new service and snapshots APIs. One of the other new things that we've released recently is some updates to Keras, and that will really help you with model design. So let's take a look at them. So first of all, if you're not familiar with Keras, and if you're new to TensorFlow and you're trying to figure out what this all means, Keras was a separate API that got brought into TensorFlow to make building high-level models easier. And that's really what it is. It's a high-level API for defining models. It allows you to create layers and just with a single line of code, specify the layer type. There's so many different types of layers that you can use. There are things like convolutions for image processing. There are RNNs for sequence or text processing. And instead of you having separate APIs for all of these, they're defined as layers within Keras. One of the really nice things about it is it's customizable and extendable. So you can create your own layer types to be able to use in a model, or any of the functions that they use, like optimizers, loss functions, those kind of things. You can create yourself and extend Keras with that. But a couple of the new things that have come out are the pre-processing layers and these new data, and there are new data loading utilities. But first, let's take a look at the pre-processing layers. So I want to consider an image like this when you're thinking about pre-processing. So this is the horses are humans data set that I showed earlier on, and this is a human from the horses are humans data set. So if you're training an AI, if you're training a model to be able to recognize the difference between horses and humans, you may be able to recognize when a human looks like this. But then if you want to classify this image, it may fail. And the reason why it fails is that even to you and me as people looking at this, we can recognize that the woman on the right is a human, and the woman on the right kind of looks very similar to the woman on the left. They have the same type of hair, they have the same, they're probably about the same height, even wearing similar clothing. And, you'd say, well, if you told me that this thing on the left was a human, then this thing on the right is also a human. But a machine isn't going to be that smart, because the image on the right to the machine looks different from the image on the left. Because, for example, in the image on the left, we see the full shape of the person. We see her legs, for example, whereas on the right, we don't see that. So if our training set only included full bodies of people, which in the case of horses and humans it does, then a model trained on that might get confused by the image on the right, and it might actually think she's a horse. Because, for example, her hair is even tied up in what's called in English a ponytail. And so maybe a classifier that was trained on this, training to see a feature such as that one, might believe that she's a horse because it sees that ponytail. But then while you're training, if you can augment the images, for example, to be able to zoom images, and so you can artificially extend your data set by being able to do things like zooming and rotating and that kind of thing. Then if it was training using an image now like the one on the left, then it might correctly classify the woman on the right, because it looks very, very similar and the shape is similar, and it's not training based on legs and things like that. Typically, if you wanted to do image augmentation with Keras, you had something called an image data generator, and which is really nice. And with the image data generator, you have all of your images directory. You can flow the images out of that directory when you're training, and then you can specify how to do the augmentation. But earlier I mentioned like things like TFDS, they have this easy API, but that for being able to take images, being able to take data, being able to pipeline the data. But that API didn't use image data generators. So when you came to augmentation, you had to find a different option. And that option often was with, when using data sets, is something called a mapping function. So as you load in the data set, you can specify a mapping function which can do things like augmentation or normalization. So you could say, okay, I could now do things like my augmentation, such as zooming within my mapping function. So now as I'm loading in my data, I can perform the augmentation on the data. And that worked pretty well. But one of the things that we've learned and what we've heard from people is that it would be actually really nice that as part of our model architecture to be able to do that thing. So first of all, it looks a little bit more consistent. And second of all, when doing hyperparameter tuning with things such as Keras Tuner, now it's a case of, well, it'd be really nice if I can start tuning things like the parameters that are used in the image augmentation. So for example, here now in my Keras, I have a couple of layers, one for doing a random rotation. So consider rotating the image a random amount, like 20% in either direction, left or right. And again, the random zoom could be every image as it's being loaded in will be randomly zoomed by 20%, like in or out. So if you have thousands of images, some of those images will be zoomed so that they look like the woman that I showed earlier on, where instead of showing her full body, it would actually zoom in to show her from the waist up. And you may be able to more effectively train a neural network to recognize images like the woman on the right. So being able to do this as part of your architecture definition provides a really interesting and powerful option. And like I said, particularly if you do a lot of neural architecture search, if you do a lot of hyperparameter tuning, now you can do all your hyperparameter tuning in one place. And it makes it pretty straightforward and pretty easy. It doesn't mean the other methods have been deprecated, different strokes for different folks. If you already have your images in a directory and you want to use the image data generator, go ahead and do so. If you want to do it as part of the mapping functions, you can go ahead and do so. This just provides another option. And as you can see right now, it's still in experimental. So I want to give a quick demo, and this is of bean disease that I showed earlier on. So I just need to figure out how to, I'm going to stop my screen for a second, and then I'm going to share a new tab if I can. Just give me one moment. If not, I will share a link to the demo and so that you can see it later on. But let's see. I'm still learning the StreamYard thing, forgive me. Okay, and I will share that again. Okay, let me see. Yeah, there we go. So this Beans demo is a simple neural network that I created using some of the things that we were talking about earlier on. So the idea behind it is, I'll just import some stuff. The idea behind it is that this is going to train a neural network to be able to recognize bean disease. So I'm going to do my imports here. I'm going to use TensorFlow Hub. And in TensorFlow Hub, I'm going to import an existing model, which I'll show in a moment. But here I just want to show the TFDS that I mentioned earlier. So there's a data set called beans in TFDS. This has splits in the data set for training, validation, and testing. So I'm just going to import that effectively with one line of code and get the data set with those 3 splits in it. And when that is done, I will show you the mapping function that I'm using. I'll let that continue loading. So here I'm using the mapping function option that I spoke about earlier on. I'm not doing any image augmentation yet, but things, for example, like if you want to normalize your image, typically by dividing each channel by 255, you can do that as a mapping function. So I am going to create my mapping functions and create my data sets and get them ready for training with that. In TensorFlow Hub, you can take existing models and you can take chunks of those existing models. And a popular model for machine learning that you've probably seen in demos is the cassava disease one. So all I'm going to say here is I'm going to take a chunk of that model handle and I'm going to define my architecture using that. So I'm just calling that feature vector here, where I'm taking that layer from Hub. But what I want to show off mostly is the pre-processing layers that we spoke about. So now you can see my actual model architecture is very, very simple. So I'm just creating a Keras sequential. I'm putting my pre-processing, randomly flipping, randomly rotating, and randomly zooming that object. Then I'm going to use the feature vector from Cassava, and then I'm just going to put a simple classifier underneath that one. And that's it. I can compile that model then, and I can start training with the model. I'm not going to train now. It'll take a little bit too long, but here's one where I pre-trained, and we can see that my accuracy on beans rose very sharply, very quickly. It started at 78%, it rose to 90%, then 93%. And by the time I'd done 20 epochs, it was at 96% on the training set. Now, often what will happen is if you train without doing augmentation, in particular on images, your accuracy on your training set might be very high. But then if you try to take a look at images that the model hasn't previously seen, your accuracy on validation might be a false high because it's making guesses based only what on the training has seen. But in this case, I'm using augmentation. And with my augmentation, I decided to do that random rotation, et cetera, and now I'm not overfitting in that way. So I can see the better accuracy score for me here on the beans is like 83% because I'm doing that augmentation to prevent overfitting to just what was on the training set. So by looking at my validation accuracy and by tweaking my augmentation parameters or tweaking the rest of the hyperparameters on my model, I can actually build a better model. I trained this one earlier on just so we could see. I could learn from this training the mistakes that I made. This crazy zigzagging that I'm getting, particularly on the validation accuracy, is telling me that my learning rate is probably set to be a little bit too high. I can tweak that a little bit lower and retrain it. And then if we want to show a few examples, hopefully I've saved some out here. Yeah, so if we want to show a few examples, then we can see things like, you know, on this leaf, it has leaf rust and it predicted leaf rust. It got it correctly. And from just looking at some of these images, I can tell that when it finds brown blotches, it thinks it sees leaf rust. So in this case, for example, this leaf actually had when it finds yellow blotches, then it thinks it has angular leaf spot. And we can see here, this leaf actually had leaf rust, but it was misclassified as having angular leaf spots. This one correctly has leaf rust. This one correctly was healthy. So even by looking at the predictions and making my own parse on these, I can start beginning to see where the classifier got it wrong. So I can start tweaking my hyperparameters. Maybe I can start adding some new processing layers to be able to go beyond that kind of thing. So I can share this collab out with you if you want to play with it for yourself, but it's pretty simple to also build one. So let me continue the presentation. So then the other thing in Keras that we've added that's quite new is new data loading abilities. So earlier I mentioned that you can use TFDS, but often the data isn't available in TFDS. And for example, you might have images that you've saved into a directory and you want to be able to create those images into a pipeline quite easily if you don't want to put them into TFDS. And then the idea here is with these new pre-processing layers, that's exactly what we're doing. So for example, if you have a directory, like here I've specified a directory data/horse or human, and if I want to be able to use that effectively as a data set and use a lot of the benefits from the data set, now I can just say my data set is tf.keras.preprocessing.image data set from directory. And there's a few different options there. There's like text data set and stuff like that. Give it the directory and then also specify things like the splits within that. So here I'm saying validation split equals 0.2. What that's going to do is it's going to take 80% of the images for training, 20% for validation, that type of thing. And it's also things like resizing them. So if those images are lots of different shapes and sizes, as it flows them into the data set, it will resize them to your desired image width and height, and it will batch them according to what you've done there. So again, instead of you writing a lot of code, I wish I'd had this when I was creating the Coursera courses, because if you look at my Coursera courses, and particularly the convolutional neural networks one, I spend a lot of time talking about how to download a zip file, how to break that zip file into training and validation, how to store that in directories, how to separate into different directories based on labels, et cetera, et cetera, et cetera. And as all of that type of code ends up being now split and like being able to condense into a single line of code like this one, which I find really exciting. So a couple other things beyond Keras and beyond the new things in data is that there's some tools really for profiling. And there's a couple of new things here. There's a memory profiler and there's a Python tracer. And again, this QR code will give you a link to the documentation where you can explore these and try them out for yourself. But for a quick look at them, the idea behind the memory profiler is that if you have a number of devices, like if you think about the pipeline that I was showing earlier on, and if you have a number of devices that you're using in your system and you're trying to figure out your memory bottlenecks, because if you think about the pipeline of your CPU, and your CPU is probably doing the job of pulling in the data, preparing the data, maybe even things like augmentation on the data. It's passing it over to your accelerator, be that a GPU or a TPU, that's handling the training. And like if you have a complex architecture within that one, then that might be needing a lot of memory to do the training. And you want to see where your memory is being used, how it's being used. And in particular, if the memory is being fragmented. So for example, if a chunk of memory is allocated, but it's not all given back. A chunk is allocated, it's not all given back, and you end up with a memory leak. To be able to see where in your process this is happening is possible with the TensorFlow Memory Profiler. And then finally, there's also a new one, which is really your Python tracer. And sorry if this diagram isn't a little bit clear, but if you go to this QR code, you'll see an example in tensorflow.org where this is documented. But the idea here is that, you know, if there are various parts of your life cycle of your code that you want to be able to trace, like for example, here, this looks like a custom training loop. And within my custom training loop, I'm pulling in stuff from the data set and I'm training using that data. I might want to see how Python is using resources during that. Am I writing inefficient code, for example, that overuses memory? Am I doing it incorrectly when it comes to like how I'm serializing or deserializing stuff off disk? That type of stuff, right? Like when you really want to get down to going beyond the machine learning optimization and into the code optimization, then the Python tracer is something that's really handy for you. And again, this QR code gives you details of that. So that's it. That's the end of my time presenting. I wanted to leave some time also for questions. So if anybody has any questions, I'm here to answer.
Thank you so much for the amazing session. As always, let's see how many questions. We have many questions, but let's see. So the first can from Ritu, can images be trained in a for loop? Does the model weights can updated the way when we train a model with entire data set?
So if I understand the question right, then the answer is yes. So you can create a custom training loop yourself. You don't have to use like Keras layers like I showed earlier on. So with a custom training loop, then you can create your own loop and train like for recognizing those images any way that you like. And yes, the model weights can get updated the way when you train a model with an entire data set. Usually with images, you may be training, for example, a convolutional neural network where the top layers are convolution and pooling, and maybe the bottom layers are dense classifiers, like I was showing with the beans demo earlier on. And if you're doing a custom loop, then on like even in a sub batch within a loop, then the model weights will be updated.
Thank you so much for that answer. The second question is from Akhil. Is the processing performed on every input image? Would the pre-processing methods get saved when we serialize the model?
Okay, great question. So yes, to the first part, the processing is performed on every input image, and by default, it's like a random amount per image. And then to the second part of the question, will the pre-processing methods get saved when you serialize the model? Then yes. So if you're using the Keras pre-processing layers within the model, when you save that, the parameters behind them will get saved. But if you run the model to train another time, the parameters will be applied randomly per image, so you won't get a deterministic result. If you want to have a deterministic result based on what you, based on the pre-processing that you've done on the images, it probably would be better to use the snapshot API that I was talking about earlier on.
Thank you. Sridhar has another question. Is there going to be a support for EDA in TensorFlow 4?
I'm not familiar with the acronym EDA. I'm trying to think, what is EDA? Maybe if Sridhar comes back later, or...
Yeah, Lawrence, that's exploratory data analysis.
Exploratory data analysis. Can you explain what that means? I'm sorry, I'm not familiar with it.
Yeah, so when you have a data set, you sort of first understand what the traits of the data set is. You sort of take out all the, descriptive statistics of your data set. That entire process. Facets might be your guy here.
Yeah, so I guess in that case, that kind of thing you could do in the mapping function within the data, or some kind of pre-processing before you publish the data to stream it in, or something like that. So sorry, I'm just not familiar with the acronym, but of course, in TensorFlow Core, the idea is to give the tools that you can use for preparing the data and for passing it, for training with Keras and that kind of thing. So if you've done some kind of EDA and you want to maintain that, then you could use the snapshots API. If you want to write the code for EDA that becomes part of the, bringing the data in, then that could be done in a mapping function in TF data, that type of thing.
Okay, that's noted. I think this is going to be our last question, and it's probably one of the most asked questions. It's about, when are you gonna come next on Coursera with a new specialization?
Yeah.
The Coursera folks are going to be really happy to hear that question. So I'm actually working on an advanced TensorFlow specialization at the moment. I finished writing and filming the first course. I'm currently finishing writing the second course to film it sometime in the next couple of weeks. I believe they want to launch those first courses in October. So it's coming pretty soon. So the idea is it will be an advanced TensorFlow specialization, like I mentioned. The first two courses are going to be on extending Keras that I was speaking about earlier on. And also the lady that had the first question was asking about looping in images, so custom training loops. That's the type of stuff that's in the first two courses. And then the second two courses will be getting into things like GANs and like being able to generate content with GANs. Like you've probably seen some popular samples where you can turn a picture like into an anime style picture, and do style transfer, that kind of thing. So this will be in the later courses that hopefully will be out maybe November timeframe. But right now, the idea of the first two courses in the specializations, that's extending Keras and then some advanced image processing, will be out next month. That's the vision anyway. Hopefully I have time to film them.
That's awesome. If you have not watched it, go watch ML Zero to Hero and also watch NLP Zero to Hero. They both are also awesome courses available on YouTube directly. Okay.
Thank you.
Thank you so much. Also, I had one more question,
Sure.
which is like about TinyML course. So there was one more comment in the live as well. So when is that course launching?
So there's a TinyML course being created with Harvard. It's not on Coursera. Oh, well, my one is not on Coursera. Just see the question now. So Harvard edX are creating a TinyML course. I'll be teaching that along with Pete Warden from Google, who wrote the book on TinyML, as well as a Harvard professor, and his name's Vijay. And so that, I believe, is coming out sometime in the next couple of months. We're still working on that at the moment. But if you want to learn TinyML now, I definitely recommend Pete Warden's book. I can't remember. I think it's just called TinyML, and it's available on O'Reilly, and it's terrific.
Amazing. Also, everyone, if you are not on Twitter, get on Twitter. I guess from the morning itself, we had fun on Twitter, and we swapped the names of Lawrence sir and Sandeep sir. So if you're not on Twitter, just if you're on Twitter, just go there, use the hashtag TFUG India Summit, and we are having much fun there. Thank you so much, Lawrence sir, for coming and sharing your knowledge with everyone. Thank you so much for being part of TFUG India Summit.
Thanks, everybody. Looking forward to when we can do this in person.
Yeah.
Take care.
Okay, so next we have, okay, so I guess we do have a question for Manning.
Yeah, we can announce the Manning thing before we get on to the next speaker.
Sure. Yep. So everyone who's participating in TFUG India Summit, we have a special coupon, and we have 30% discount on all this 5 books out there sponsored by Manning. So please go ahead. They will be publishing a tweet, as well as we'll be putting that maybe in the live chat. So yeah, you will be here. We will also email you as well. So thank you so much, Manning, for being a sponsor. Okay. Now I would like to hand over the stage to Sayak again, and thank you so much.
Yeah, so I'm back first and foremost, but the thing is, we are absolutely more than right on time. So we are going to have to wait for a couple of minutes, not more than 3 or 4 minutes, for our next speaker to join the stream. Meanwhile, I have something for you guys. I guess Anirudh has already joined. That's amazing. So yeah, I'll keep the secret for some time now. I'm gonna bury it, and I'm just gonna head right to the next session. So our next speaker is Anirudh. Anirudh is currently the ML lead on the NASA's FDL team. He has been a scientist at Microsoft AI and Research before. He is also one of the co-authors of the highly popular O'Reilly book called Practical Deep Learning. I mean, I don't know the kind of stuff I have grasped from that book, and I cannot be more thankful enough to all the authors of that book. And if you haven't checked that book yet, and if you are into deep learning, please do that. Please do that after Anirudh's session, of course. So yeah, I mean, without any further ado, as they say it, I'll hand it off to Anirudh. Anirudh, why don't you take it away?
Welcome to my home. Thanks for joining in. Really excited to be here today to give the session on 30 golden rules of deep learning performance. So we are talking today all about TensorFlow. So we said, why don't we take this off like a fast car and show you some practical tricks that you can apply in 1 to 2 lines of code with your deep learning training and potentially some inference. And I guess you can already see my screen. So let me try to bring it ahead. Hi, so I'm Anirudh Kaul along with Siddha and Meher. We, based on our trying to get TensorFlow to run in industry and on products, we got to learn some tricks that we wrote in a book, Practical Deep Learning book. 2 of our famous readers that we found the definition of recursion. You wrote a book for Keras, and then somebody who built Keras is reading it. So that was exciting. So that's recursion. But the coolest story we recently heard was the last page of the book basically goes and teaches into how would you build mobile phone apps, things on the servers, on devices, on robots, and then finally into self-driving cars. And the last page was basically about if you have taken the skills correctly up to now, maybe you can go and apply them on a 200 mile per hour real racing car. And turns out that dream actually came true. So some readers are now building the AI for the robo-race autonomous car. So let me get to, now that my sales pitch is over, let me get to like the key thing that we are here about. So most data scientists, most people who train models have like one common excuse. Programmers have the common excuse that their code is compiling. For people who train their models, the common excuse is that their code is simply training and you keep waiting. And this hits me very personally because I train most of my living life models. So here was a really interesting example. My weight, I was looking at every morning I basically check my weight. And in 2017, my weight was like rapidly dropping over a period of 2 to 3 months. Rapidly dropping by like about 15 pounds. And around the same time that I was training a production model for day and night. And what I noticed is the more I would train my model, the more body weight I was losing, which made no sense. So it turns out in my office, we had a long pathway, and it would take us exactly about 2 minutes to walk around that pathway. So I changed the batch size of my program and tuned the TensorFlow pipeline so that it would make one entire epoch every 2 minutes. And during those 2 minutes, what I would do is I would go and take a walk. And so the more I had to wait for my program to train, things would happen. So I went from 8,000 steps a day to about 15,000 steps a day. And that is obviously visible now when I lose weight. So in summary, the more I would wait, the less I would weigh. And I don't want you to do that. So I asked a friend, like, if somebody wants to reduce this waiting time while training the program, what could they do? And here's what they said.
This is like common sense. The more GPUs you buy, the more money you save. That's right. The more GPUs you buy, the more money you save.
Well, we could follow his advice, especially if your boss has good budget. But as you might have experienced painfully in my own life, there are sometimes things that you want, and then there are things that you can really afford. So my question to you is, what if you could tune the car on the right-hand side to work at the same speed as the car on the left side? And that is what we are going to talk about in this particular session. Now, unless you can measure, you cannot improve. So we have a few tools to measure how good or bad we are doing. And those are the tools of the trade. So the first one that I want to talk about for measuring if you are good as a baseline and where you can find opportunities to improve is obviously TensorBoard Profiler. TensorFlow Profiler is available within TensorBoard. And as you can see in this image, what it's showing is that it captured a training pipeline. And something interesting is notable here. The first line you see at the top is the line showing the CPU usage, and the line at the very bottom is the line about the GPU usage. And you can probably notice the GPU part here is totally empty. What that means is that your CPU took the cycles here, and the GPU kept waiting. And then the GPU started doing its inference, and the CPU is waiting. I hope you can see like one device is running at a time, and in a multi-processing system, we are basically waiting for one to finish while the other could have done the work together. So this is an opportunity that we could improve on, but TensorBoard Profiler is one of the cool ways you can use it. And it's really, really simple. All you do is when you're calling for your callback functions, just include that with like one line of code. And you can now go to TensorBoard and see the TensorFlow Profiler. Easy, right? Well, it can be a little bit intimidating, especially for somebody who's starting new. So an even easier way is this NVIDIA SMI command. SMI stands for System Management Interface. And with all the nice numbers that you see, for example, numbers like the memory your program is taking, the electricity bill you're about to get at the end of the month, it shows you this number called the volatile GPU utilization. This is telling you at a given point in time, what is the GPU utilization at that microsecond that you started off? And we want our GPU utilization to be as high as possible. So this is the number you really want to optimize for, and you want to bring it as close as to 100. If you can get to 90, I think it's a good day. And then to run this command, you can write NVIDIA SMI. You can write it in Colab, or you can write it on your terminal. But you could also write watch command before it. And what this will do is every half a second, it will run that and refresh it. So when you're training a pipeline, every half a second, you can see, okay, before I started my program, it's 0% utilization. And when I started, it's at 50% utilization. So there is opportunity to improve. So I was thinking about like how to structure this presentation so there is something valuable coming out. And a good way to thematically present it is if we combine portions about preparing the data, then reading it. After we have read it, we need to argument it. Finally, we train it, and then we do inference over it. So let's start with each of the sections individually. Data preparation. So the first golden rule is store your data as TF records. So there are two bad ideas that we should recognize outright. Storing tiny files, thousands of tiny files, as well as storing one gigantic multi-GB file. So image data sets, quite often when you resize them down, would maybe be around like 100 kilobytes or maybe even smaller. Some of the text files can be way smaller than that. And that is a bad idea, because just trying to go through the overhead of reading each one of the files is enormous. On the other hand, if you have a magnetic hard disk, trying to seek to each one of these files is even worse if you don't have a solid state hard disk. Bad idea. And then the other bad idea is if you have like one gigantic multi-GB file, because if it's one gigantic file, the chances that you can parallelize your reads, and if it is on a cloud-based system, parallelize reading through network calls just becomes even harder. So in each one of these cases, your overhead or your opportunities to parallelize reduce. So what's the golden idea? The golden idea is that you combine thousands of these tiny files into a handful of large files and hope that each one of these files is about 100 MB in size. So the golden thumb rule is try to combine files to either break them out or combine them into 100 MB size. That's like a good sweet spot that you might want to adhere to. So that's number one. And do it in TF records because it is efficient for reading, especially for TensorFlow. The second good idea is to reduce the size of your input data. So when you try reading and you augment it, sometimes when you take a big image, you resize it down. The resizing step is common, and you then resize it down into 224 into 224 size. Why don't you do it? You do it once, and then you do it again, and you do it again over each and every epoch. That's where you are wasting your CPU cycles. So why don't we read the images, resize it, and then save that as the new TF record? So every time you have to read the files again, you don't have to bother with normalizing and resizing. So all the things that are very common to your pipeline, just find what is common and then save them as a new TF record. So next time you reduce on those CPU computations. That makes sense. Number 3, why don't you just, instead of going to downloading a brand new data set yourself, trying to figure out the formatting, then writing the reader for it, and going through all the blah, 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 why don't you just use TF records if it is already available? So TensorFlow datasets probably already has 200 plus datasets available, and this is a growing dataset place. So why not just go to TF records and in under 2 lines, call the name of the dataset, get your splits into train and test, and then run this data pipeline. The point is it is a high performance pipeline in 2 lines of code. Can't get a better idea than that to go faster. So if that's one thing that you learn from this presentation, it is to use things that are already out there and reduce your effort. By the way, if you want to actually become famous, here's a quick tip. Publish your dataset on TensorFlow datasets, and others will start citing your work. Your research paper will basically start getting citations for free. So do it. All right. Now that you have these 3 rules, let's see about data reading, and can we make our data reading pipeline faster? And the one thing that you want to take away from anything I said, forget about what I said before, was tf.data. This is the key to building high-performing TensorFlow pipelines for data. You go with TF data, and you can compare your speed before and after. So what I'll do here is I will show you this piece of code using tf.data. And what we'll go over the next 5 slides is optimizing them to become faster and faster. Nothing really important is happening here. What it's doing is it's reading all the TF records in a particular folder. It's creating the TF record dataset. And then we are doing shuffling. Yeah, you want to shuffle. It's repeating so that it keeps getting that infinite stream of data. It's running through a parsing example. It could be your own personal example. It is resizing and batching. So this is a good place to start with, and then we'll try to add one thing at a time to improve the speed. So the first reason for why things are usually slow, as I showed in one of the first slides, was that the CPU is trying to read data, and then it does a few augmentations, and then it gives the GPU that, hey, take this data and train it. The GPU is all this time waiting for this data to be passed in, and then when it gets the data, it starts training. And then the CPU is waiting all this time. So the CPU is waiting for the GPU is waiting for the CPU, huge amount of inefficiency. What if we write the data that's processed out of the CPU into a buffer? The moment the data comes in the buffer, the GPU is basically happy and gets that data from the buffer and starts working on it. So the CPU never has to wait for the GPU. The CPU is literally going and pushing data to the buffer. The GPU is reading data from the buffer and doing its job, so it doesn't have to wait for the CPU. Point here being that by building this a middle person in the middle, you are reducing the dependency between each two. But you don't have to do that because TensorFlow has this nice little line called .prefetch. So in your tf.data pipeline, all you write is the word prefetch and a buffer size. The buffer is equal to how many items you want this middle person to have. And it's a great idea. This is like the one line which will make programs go faster. And you don't have to remember much other than this .prefetch. This is because it's doing data processing asynchronously by pushing data in asynchronously and consuming it asynchronously. Good idea. Number two, your computer has many parallel CPU cores and CPUs. So all you do is whenever you have a function that you want to run through, you can parallelize the number of calls. So in this particular example, I had this particular function, parse single example, and I used the num parallel calls and gave it a number. And now a good idea is that this number is equal to the number of CPU cores, and it does a job like the name says, number of parallel calls. So speed goes high. Also, this is for processing a function, but sometimes you're just reading the data, and you can also parallelize that using interleaving. So in this particular examples, I had files that I was interleaving with. And again, by setting the number of parallel calls, I could parallelize the I/O, the reading. Think of examples when you're reading from the cloud, that could actually get even faster. And if you have files on the disk, that gets faster too. Other examples include non-deterministic ordering. Sometimes in your datasets, some files there are many tiny files. Let's just assume we are still in the old age. We didn't follow the first rule. We have many of these tiny files. And then there's one big gigantic file. So what will happen is it will read file 1, 2, 3, this one big gigantic file. And while waiting for this one, reading this gigantic file, all the files which are after that kind of got stuck. It didn't read the files after because it's waiting to read this one gigantic file. And these threads which are reading these gigantic files can be stragglers. This is an example of a straggler thread which just got slow because of that one single operation, and it can hold up the entire queue. So now when you're doing deep learning, you often want to shuffle data anyway, so you don't really care about the ordering, right? If it's out of order, fine. And that's what we are doing here. What we are turning on is this experimental option called turn non-deterministic ordering. So you don't care about this data being like in the perfect order. It can be in out of order. But by turning this on, your straggler threads will start to, if it's straggling on one thing, it will still read the other things after this. And this makes your thing faster. So basically, you turn the experimental deterministic to false. Finally, caching is the age-old thing used for making things fast anyway. So if you're reading your data and you can cache the data set. So in epoch number 2 and epoch number 3, once it has already run through the system once, wherever you write this line .cache, everything above it is cached in memory or on disk. And everything after it will always be read from the memory. So you'll notice that at epoch 2 and onwards, your speed will just massively increase by putting this on .cache. Now, quick tip, if your data set is up to a GB, 2 GB, or it can be fit in memory, excellent. But if it is a little bit bigger than that, you can write file name equal to and write the name of a file, so it actually uses the disk as your cache. So you don't crash your program because of the memory. There are other experimental optimizations I won't get into, but you can fuse some of the operations together. But here's the last important thing. All those numbers I was showing you till now, that number of parallel calls, it's equal to the number of cores or number of CPUs, or what is the size of the buffer. These are a number of numbers that you can tune. But what is the right number? Because on your machine, maybe imagine that this works nicely. But then when you go to Colab, on that particular virtual machine, this will be a different setting. Then you go towards, on the cloud and you have multiple machines set up, the numbers might be different there. And let's say that it's a multi-GPU system and somebody else is also training at the same time, the number of available CPUs, reduces. So tuning these numbers will be different from machine to machine. So how do you find that best number? Well, the easy thing is you don't need to do that anymore, because you just write the simple line tf.data.autotune. And when you do that, it will use something similar to gradient descent to find the most optimal numbers for your machine. That's kind of like using AI to make your AI high-performant file training. And so my pipeline that I showed on one of the early slides basically becomes into a much faster pipeline. Quickly showing, we interleaved the reading in this line. We basically put number of parallel calls while doing our pre-processing. We cached it so that every time it read next, we did not have to do any of the steps above. And then after that, we put prefetching. And in all these examples, we had auto-tune. So that's how you can make a high-performant training pipeline for TensorFlow. This is great, but you can do even better than here. So let's go over some of the more nitty-gritties in making things faster. Number one, if you're from the Keras world, life has been good, especially when you're doing things, it's easy. One of the things that maybe is not so good is that all the augmentation functions within Keras that you see usually are running their augmentations on the CPU. And you have this expensive GPU sitting there waiting, looking at the CPU, doing these augmentations, and like, what up? Instead, what you could have been doing is doing those augmentations using the power of the GPU. And luckily, the core TensorFlow has those GPU accelerated options. So for example, you wanted to crop things. You wanted to change the hue, the contrast. You wanted to rotate the images by 90 degrees. Those all functions are accelerated by GPU if you use the tf.image pipeline. So instead of using the normal Keras augmentations functions, here we are using the tf.image pipeline, and you will see the speed up that you will get. Now, the Keras-based augmentation functions make life really easy. Okay, I will agree, because there are certain functionality that's still not available here. For example, if you have to rotate images, you cannot rotate images by like 30 degrees or 20 degrees. You can only rotate them by 90 degrees. So if there are good people hearing out there and you want yourself to be famous, try implementing many of the same augmentations and tf.images, and everybody will be thanking you. By the way, there is another tool called NVIDIA DALI, which does some of the data reading part, augmentation part, resizing part by hybridizing the CPU and the GPU. So as much of the computation is done on the GPU. And this was used to train ImageNet in under 80 seconds. So this is like an additional toolkit that you could have used to do all the data reading to augmentation pipeline to get to your normal TensorFlow training. So that's a good idea. Now, I will quickly go over a couple of tricks. Now that you know how to read the data fast, which is majorly the source of inefficiency, now that you are already good at reading it and augmenting it and pre-processing it, let's just go through a couple of tricks on your training side of things. And this is like agnostic to how you train. Rule number one, use mixed precision. The TLDR is that it might just make your training 2 to 3 times faster. I won't go into all the details, but basically the idea is as follows. Most of your training usually happens in 32 bits. But imagine if you had gone and done things in 16 bits, that would take basically half the memory requirements of passing in all the data. So your memory bus, your storage, your memory, all those side of things basically can get 2x the advantage. But if you try training in 16 bits, like not so fast, Jack. It's hard to do. There is a lot of numerical instability in training in 16 bits. So you can infer in 16 bits very easily by just reducing the size from 32 bits to 16, but training is not so easy. And this could be an entire session in itself, but luckily, to the forces who may be, have already implemented something called as auto mix precision, AMP. And by just writing the OS environment variable at the top, it will, on certain machines, on certain GPUs which have the power to do it, it will train in 16 bits and save the master copy in 32 bits and do it in a way that the numerical instabilities go away. Number two, batch size. Batch size is incredible at making your programs faster. So imagine this: I have MobileNet. Okay, let's call MobileNet or MobileNet V2. It's somewhere around. Let's pick ResNet. Okay, ResNet is somewhere around 97, 98 MB. Let's call it 100 MB. And I have a GPU which is about 10 GB in size. So I could numerically think that if my model is 100 MB on a 10 GB machine, I can technically, if each image will essentially take about 100 MB in size, then I could fit 100 images per batch before crashing. That's how I would think when I pick a new model and the images that I'm going to fit in it. So if I think through this, my math would say that if I take a MobileNet model and I have a 2080 Ti NVIDIA GPU, there's a big number that I can fit in for a 15 MB model, the number of images in the batch size I can fit. And that's the experiment that you have to do to increase your GPU utilization. So in this example, the line that you are seeing here in blue is showing the time per epoch as the batch size increased, and the red line is showing the GPU utilization. And remember, we wanted to increase the GPU utilization of our system. So when I was at 10 images per batch size, what's happening here is that it was using about, I'd say, about 25 to 30% GPU utilization, and it was taking close to 90 to 80 seconds per epoch. And by the time I was around 500 batch size, the time per epoch was already under 10 seconds, and my GPU utilization was close to, the 90th percentile. So the learning here is that you have to experiment on. I usually try to find the number before I'm about to crash and keep a 2 raised to power something batch size before crashing. I will say this will have an effect on your training. So unless you are using an optimizer like LARS, don't go too high. But like a number like 512 or 256 could be a good number for trying to train. The other number is a golden rule is to put everything that you have in the powers of 8. So the story is that, look, we had CPUs, then GPUs came out, which paralyzed things, and that made life easier and faster. And then these accelerated devices came out, like tensor cores and TPUs, which will have a specific matrix multiplication size. And most of them have some optimal multiplier of 8. So in this particular example, which was done at NVIDIA, they noticed that when they were changing the batch sizes, when they went from odd to even, they somehow had a 5x increase in speed up. They also observed that not every even number is good. As you can see here in the different batch sizes, some are fast, some are slow. And the reason turns out to be that in these special hardware requirements, they have some minimal requirements for TPUs, for tensor cores, to be able to accelerate. And when it doesn't find that minimal requirement, which is the power of 8, it goes down to the normal accelerator, which is your GPU. So always use the power of 8 for the number of channels in convolutional filters, for the number of neurons, for the size of mini batch. I mean, this is easy, right? For TPUs, if you use TPUs, I recommend using 128 because I read that in the guide. And for NVIDIA GPUs, use 64 or 256 as the recommended size. Becomes easy. Now, if you're heavy into training, using the optimal learning rate will give you the big bang for buck. I won't go into details, but there is a number that it's the optimal number you start with. You won't have to wait too long to get to that. And there are a number of libraries that can help you. Keras LR Finder is one of those examples where it implements algorithms like the cyclic learning rate for training, neural networks, where you can find the sweet spot in these 3 lines of code to find the learning rate to start from, which will lead to the smallest time taken to converge. And I think there's always a good number to start with. Quick, before cutting, some really quick functions. TF function, use it judiciously. Here's a quick example before I even get into detail. You see this example at the top? I ran that. All it has is a single convolutional layer, right? Nothing special. And this is exactly the same function here, but with one tiny change. This is the TF function written on top of it. And we ran it and saw something interesting. The same function with TF function written had a 10x speed up. 10x speed up by just writing that single line above it. So what's happening behind the scenes? Back in TensorFlow 1.0, everything used to be compiled as a graph and used to be executed in one go. In TensorFlow 2.0, it's built for experimenting and being a little. You write a line and it runs. So it's like eager execution is turned on line by line, and that's great for debugging. But sometimes there is a potential overhead that can add for tiny tasks. So the point here is that TF function will, things that you want graph-based execution to speed up, you want to write TF function. But the biggest benefit that you will get is on those tiny functions, especially which don't have as much computation requirement, but you might have to run like million to billion times. Those are the functions where you will get this great speed up. Last couple of things, and this is something very generic. You want to train. If in normal life I tell you, hey, would you like to learn French? What you could have done is you could have learned an entire dictionary. Or I might give you 50 most common words in French and you learn them. And once you start getting confident, at that point, we'll break your confidence and show you 100 most common words. And progressively, by getting you more confident and then breaking your confidence by showing you more words, you'll start to realize how good you are and keep getting better much, much faster than just trying to go through an entire dictionary. That is just hard and you'll never finish. Because I didn't. So we can bring the same learning to TensorFlow training by 3 things. I couldn't find a research paper on this, but I have been doing it for years. And so I say overtrain and generalize. So the idea is that you first try to sample your learning in some way to overtrain first, and then you generalize. So let me show you a couple of examples. One example can be you use progressive sampling. So imagine that you take ImageNet and instead first train on 10 classes. Then you train on, once you start getting better, you then train on 20. You then train on 50, 100, and 1,000. So progressively, once you've learned something first, then you start going, bigger and bigger. Similarly, augmentation. So when you start augmenting, start with like no augmentation at all. It will start to overtrain. And then once you start to learn something, then you start rotating it by 10 degrees, 20 degrees, 30 degrees. Jeremy Howard in Fast.ai has a similar term. It's called progressive resizing. And the idea there is that an image, if you resize it by half, that's about 1/4 the size. And if you resize it by 1/4 height and width, it's about 1/16 the size, and that means 16x speed up. So first train on smaller resolution to learn the high-level details, broad shapes, colors, and then you try to fine-tune with higher resolution, so it starts to learn those fine-grained details faster. Last few things. Hey, the TensorFlow binaries are built for everybody to run easily, but if you actually build it for your particular hardware stack, it gets even faster. So if you can find the machine instruction set that you particularly have, and if you're running on an expensive computer and not on a Raspberry Pi, you could build it yourself and get faster. Anaconda has a special library, especially if you're trying to train, on a device where you could utilize the Intel's MKL library. That's good, and you might see faster inference performance, especially when you're training or inferencing on CPUs. I have 1 minute left. So you know what I'm going to do? I'm just going to tell you one very, very quick things. Oh, by the way, you can also set the parallel optimization for the number of threads that you want, and that's fast. You can spend more money on machines, obviously. But the one last thing that I want you to take, if you have more machines, you can use distributed training. But what I do want you to learn is that there are industrial benchmarks where people have open sourced how they were able to train without much money. So in this particular example, somebody has trained an entire ImageNet in $7. So you don't need to be, a millionaire. You just need $7 in your pocket to train on entire ImageNet. But the thing I want you to learn here is the source code is available of how they built that whole thing in 19 bucks. The other point is that you can train an entire ImageNet using in about 2 to 3 minutes. And actually, this is old. So there is hope that if you don't have much money, or if you're really impatient, one or the other, you can go and at the end train. The recent benchmarks basically show that people have trained it within 90 seconds. So there's always hope. By the way, if you need these slides, all you do is send an email, wget TFUG presentation to Practical DL book. And I have this nice little one-pager that you can put on your fridge. And basically, whenever you are training it, you just have to go through a checklist of things that have you optimized or not. And hopefully, I hope your training gets faster. Thank you, everyone, for joining it. And I hope all these incredible sessions are giving you learning, as I'm learning here. Thank you.
Yes, I mean, it was amazing having you here and actually being able to hear all the stuff that you folks have written in the book and actually be able to listen to them in person from you. So I just had this one question. When you mentioned that setting that particular automatic mix precision environment variable will just do the trick, but my guess is that it will do the trick only on the NVIDIA Dockers, right?
Yes, that was the caveat, that you need to have the new Tensor cores for that. Usually when underneath the hood, with the good work done, by Google, if you're using, depending on the underlying setup, things would go faster. Usually the thought is that it'll either not go fast or go fast, but you should usually not get slow. In some cases, people early on had seen things go slow, but hopefully that's not the case anymore. So whatever I say, I always, then next time I'm running the program, I check what happens if I remove this or not, or see the TensorFlow, the release instructions if anything actually changed through that. But it's just generally a good idea to put it. If you're using Colab notebooks, you don't know the underlying GPUs might have already improved behind the scenes.
Yes, that's absolutely fine. I mean, that's absolutely right, in fact. So one last question would be, someone asked that, have you ever experienced any performance drops when using automatic mix precision policy?
I've heard. I haven't. In all the cases that I was sadly trying to implement it, which is a totally bad idea, instead of writing that line. But I have heard people have seen slight slow ups happen in their cases, and that's why it's like, try it out. But because of the TensorFlow team being proactive at like hearing out, other people have said that they had seen slow ups and that didn't happen anymore. So it's like a try it out and see it for yourself kind of a deal.
Yeah, sure. And finally, I would love if you could say a few words about the Practical Deep Learning book, because it's such a rich vocabulary of all the little and large tricks that we get to know about, running things in production. So if you could share a few words.
So during my journey, I really wanted engineers in my teams to join me and build things on mobile phones, on the browser setups, on like how to scale to million to billion devices. And the common thought was that you need too much knowledge for doing that. So going through that journey since 2013, they were like always, you get to learn something by going to Stack Overflow, discussing with people, and then you start writing, okay, these checklists for yourself. and then working with your team. So I started giving those lectures on, okay, you don't need to get an entire PhD on this. This is like straightforward things that you can just apply, whether it is to learn deep learning and build a motivation with a practical industry project, and then see how Microsoft, Google, Facebook, Amazon, Apple in their personal products are using that to scale things up. And often that means, okay, the theory, this is how would a beginner would do, then how would a startup level engineer would do, and then how would somebody in the FANG companies would do exactly the same, depending on their skill set and depending on their scale they need. So this book basically goes over the journey of starting from the beginning with transfer learning, scaling search, building reverse image search engines, like Google's image content-based searches, then going towards how do you make it more performant? How do you make the training go better? Going over cloud, how to scale there, over mobile phone devices, Android, iPhones, robots, and then autonomous cars, training from video games. So I think the key thing that I've learned is that you need to have motivation for why you're about to read something or why you're about to even learn something. So instead of having theory first, it's basically here's practice, here's 10 lines of code, let's build something, and then see the theory behind it. Because once you start learning, I think you will go and learn the deep dive details. Like I get to learn from your blogs on a daily basis, like reading on the internet, and many of my students have been using, the things they have built. And just watching through their journey where they got comfortable with something and then seeked out other sources of knowledge to get better at, I think that's what learning is about. So motivate yourself first and then see how things are done in industry and then get deep dive into the theory. So that's a good flow always.
Yeah, absolutely. I mean, I totally agree with you. You need to first get excited about the stuff that you are going to try out. And once you are excited, there's no looking back, right? You are going to get to the bottom of things by hooks or by crooks. Yeah, I totally agree. So it was wonderful, Anirudh, to have you here again. Thank you so much for joining us. And thank you so much for presenting that wonderful set of tips and tricks. I'm sure many of our participants have got something to try out this weekend. So yeah, with that, I'm going to hand it over to Ali. And thanks to you again. Bye.
Bye.
Okay, how is everyone doing? I see a lot of fun in the chats going on. Yes. Okay, that's awesome. Keep engaged, okay, and talk with each other. That's great. Okay. Also, if you are on Twitter, just go there, use the hashtag TFUG India Summit, and share your insights as well. Okay. So let me not delay this and introduce to you our next speaker, Jason. Jason Mines. Jason is a very common face in India. You might have already seen him either in TFUG Mumbai or UDG Ahmedabad, and he has conducted many sessions. So let me introduce him very quickly. Jason combines his knowledge of the technical and creative worlds to solve problems and complex strategic technical challenges for Google's largest customers and internal teams. Developing innovative world first, utilizing the largest technology and hardware is a key component of his role to rapidly prototype new ideas and consult on a project solution globally. As the DA for TensorFlow.js, he is one of the public faces for TensorFlow.js, and you might be aware of the show which Jason hosts, helping the wider community to take their first steps and deliver an optimal developer experience for machine learning in JavaScript. With a background in computer science at University of Bristol, England, where he specialized in reality mining and invisible computing, Jason has been an hybrid engineer for over 15 years. Combining his passion for several areas, including both front and back-end web programming, but also design and user experience, he has worked in many sizes of company and startups, including founding his own to Google. As a mentor to many, he enjoys sharing his daily discoveries for all his curiosities online, which has attracted a global following. Without further delaying, I welcome Jason.
Hello there. Can everyone hear me?
And
nice to see you today. Awesome.
Hello.
So I'm going to go ahead and share my screen, I guess. Make sure this is working. 1 second.
Sure,
cool.
sure.
So hopefully everyone can see my screen.
Yeah.
Good
Okay.
stuff. Awesome. So, hi everyone, I'm Jason. I'm the developer advocate for TensorFlow JS here at Google. And of course, today I'm going to be talking to you about machine learning in JavaScript, of course. And the first question you might ask yourself is, why do you want to do machine learning in JavaScript? And that is a great question. And of course, if we just look at all the areas we can actually run JavaScript in, such as the web browser, server-side, desktop, mobile, and even on Internet of Things, for that reason alone, it can run pretty much anywhere. And if we dive deeper into each one of these stacks, you can see many of the technologies you know and love already. The popular browsers on the left-hand side, Node.js on the server side, React Native for mobile native applications, Electron for desktop native, and of course, Raspberry Pi for Internet of Things. And we can actually run on the Raspberry Pi via Node.js. So for that reason alone, it's a very compelling reason to kind of consider using JavaScript for your next machine learning project. However, TensorFlow JS allows you to run, retrain via transfer learning, and write your own machine learning programs completely from scratch, just like you might be doing already in Python land. So you can do all that stuff in JavaScript as well. And that means you can make pretty much anything you want, from augmented reality, sound recognition, sentiment analysis, and much, much more. So I'm excited today to go through some of these examples with you, and let's get started. So there's several ways you can use TensorFlow JS. The first way is to use our pre-trained models. Now, these are really easy to use JavaScript classes for many common use cases. And you can see some of them on the slide here. So things like object detection or body segmentation to understand which pixels belong to a human body, or even pose estimation. And some of our newer models on the right-hand side there, such as face mesh, hand pose, and even BERT Q&A for natural language processing. And all of these can run in the browser, and that has some really cool benefits, which we'll see later in the presentation too. Now, the first one I want to show you in action is something called Coco SSD. This is just a fancy name for our object recognition model. And this has been trained on 90 object classes, and you can see the kind of output you get from the system on the right-hand side. Essentially, you can get the bounding box coming back, which means instead of just image detection, which shows you a binary yes or no if something's in the image, you can get the coordinates of where in the image the object is, and even how many of them there are. So let's switch to the demo so I can show you what this looks like running live. So hopefully you can now see my demo. This is actually just a glitch example I've put together. And I can click on any one of these images and get real-time classifications coming back, as you can see right now. So here I can see that the dog is about to eat the treats because they're quite close together. So just with this alone, I can get some interesting information to make something like a smart webcam, like a Nest Cam, but basically in JavaScript. So this can be very fun to experiment with and use. But we can go further, of course. I said we can use it as a cam, and that means we can use it on real-time data as well. And you can see here, I'm live in my bedroom right now, and you can see it's recognizing me as a person with a high confidence, which is great. So it's very performant, and contrary to popular belief, JavaScript is actually not a toy language, and it works really, really fast these days. And TensorFlow JS can run at good frames per second, as you can see. And what's even cooler here is that because this is running in the web browser, it means my privacy is preserved. None of the webcam imagery is being sent to a server for classification. All of the classification is happening live in the browser as I speak. So that's really good in today's world where privacy is top of mind. All right, so let's go back to the slides. 1 second. Next one I want to show you is face mesh. This is just 3 megabytes in size, and it can recognize 468 facial landmarks. And you can see on the left-hand side, again, the type of information that comes back, but we're actually seeing it being used for many creative use cases too. And on the right-hand side here, you can see how Modiface, who's part of the L'Oreal group, use it for AR makeup try-on. So this is actually running in the browser here. This lady on the right-hand side, she's not actually wearing any lipstick. We're actually combining this with WebGL shaders to apply the lipstick to her face in real time in the web browser, so she can try on any shade she wishes before having to buy the product. And of course, in current times, this is great because you're not having to try other people's lipsticks on your face, and you don't need to go to the shop to do so either. So let's have a look at this in action as well, because this is pretty cool when it's running live as well. So let me just bring this back over here and make this larger. 1 second. Boom, there we go. So you can see, again, live in the web browser, here I am, and you can see it's tracking my face pretty robustly. But not only is JavaScript great at doing machine learning in the browser, we can also do many other things too. And JavaScript's been around for a very long time, so the graphics libraries are much more mature than some other languages out there. So you can actually see on the right-hand side, I'm rendering a 3D point cloud at the same time as doing all the machine learning on the left-hand side here. And I can drag that point cloud around and inspect my face from all different angles as I'm speaking to you right now. And you can see, even though I'm presenting to you right now, which takes up a lot of my computer power, I'm still getting like 20 frames per second. And this is running on the CPU using WebAssembly. I can actually change this to run on WebGL, and I can actually get closer to 50 frames per second by leveraging the graphics card in the browser instead. So many cool things to be done with Face Mesh. So let's go back to the slides, one moment. Next up, I want to talk about body segmentation. This is another model that we have that you can use out of the box for free. And it can basically distinguish 24 body areas across multiple bodies, all in real time. And it's hard to demo this in my room today because I don't have much space, but you can see the kind of results here from this animation. You can see how the people are really well segmented. And not only do we get the segmentations of different parts of their bodies in different colors, but you can actually see how we also get the estimation of their pose with these blue lines inside of the bodies. And that can allow you to do pose estimation and, of course, gestures and other things too. We've even seen people from the community use this kind of stuff to do yoga tutorials or workout estimators and all this kind of stuff. So some really fun things can be done with this. And on that note, I want to go into a few examples using body segmentation. With a little bit of creativity, we can actually recreate some of the superpowers we've been promised by sci-fi movies. And here's one I made in just one day of coding. This you may have seen around on Twitter. Essentially, I made this to make myself invisible. And notice as I get on the bed on the right-hand side still deforms, even though I'm removed from the video in real time. So this is better than just a cheap effect where you're replacing the image with a static image of the background. This is recalculating the background all the time and only removing me from that image. So you can notice how, as I move out of the center there, the laptop will start playing again when I go out of scene. So the background then starts updating, which is pretty cool. And we can even go further than this. We can combine this with other web technologies, such as WebGL shaders. And this guy from the community has managed to make lasers come from his eyes and mouth, which is pretty cool. He made a really cool website called shadertoy.com, I believe it is. And you can experiment with using our face mesh models to produce really cool 3D graphics. And notice how smooth this runs in the browser as well. This could be really fun for creative applications, for the movie industry, or for making things to promote such things in those verticals too. And we can go further than that, of course. Teleportation. Who didn't want to teleport when they were a kid? With a bit of creativity here, we can actually combine web real-time communication with WebXR, in this case, Mozilla's A-Frame, 3.js, and TensorFlow.js together. And now I can take myself from my bedroom, I can segment myself, I can send my segmentation over the internet, and then I can place myself in your room. So maybe in a future conference, you'll actually be able to see me presenting live right before your eyes on your mobile phone in your room. Or maybe in the future, you have actual AR glasses and you can see it with hands-free as well, which would be super cool. So lots of cool stuff you can do here to get the superpowers you've always wanted as a child. At least as what I wanted as a child. But of course, we can go beyond just superpowers, and we can make many other delightful things too. And here's another demo I created in just a few days of work over the weekend, which allows me to estimate my clothing size in under 15 seconds. Most people know their height, but they don't know all the body measurements to get their perfect fitting clothes. So here, I enter my height, and I can then figure out, using body segmentation, all of the other measurements that I need in order to get a good measurement of my various body sizes. And now on the website, the brand can automatically select the small, medium, or large that is required at checkout for me, rather than me having to guess. And of course, you can combine this with even more technologies. We spoke about WebXR, WebGL, and this guy from Paris, who's part of the TensorFlow.js community, has done that for fashion. So he can open up any fashion magazine, he can find a body in there, and he can then transport that body into his living room using these cool particle effects to then inspect the clothing or the style in more detail. And I believe in his latest update, he's even managed to make them talk and bring them to life a little bit, which is super cool. And I'll show you how to find out more about these projects at the end of the show. So do watch out for that. Now, the second way you can use TensorFlow.js is via transfer learning. And essentially, what's really interesting here is that you can retrain some of the models that you've seen already with your own custom data. Obviously, the next logical step, once you've used our pre-made models, is to try and use such things on your own data sets. And I want to go through some very easy ways to do that with TensorFlow.js. Of course, if you are knowledgeable, you can, of course, use our low-level APIs to do all this programmatically. But I want to show you two easier ways to do that if you're just getting started in the machine learning world. Now, the first way is to use something called Teachable Machine. This is a website that's been created by Google, which allows you to do both the training and the inference live in the web browser. So everything is done in the web browser. And the best way to show you this, of course, is to show you a live demo. So over to my Chrome. So if you go to teachablemachine.withgoogle.com, you'll be presented with a page, something like this. And right now it supports recognizing images, recognizing audio or different poses. And of course, more to come soon. So hopefully more of our models will be ported over to this format soon. Now we can click on image project, for example, here. You can see we're presented with two classes. Now, if you had more than two objects you wanted to recognize, you can click add a class, and you can just add as many classes as you like. But for this demo, I'm going to change class 1 to be Jason, and class 2 is going to be cards. I've got a deck of cards on my desk here. So all we need to do now is click on the webcam, and we can actually start taking sample data live from the webcam input. So I'm just going to look at my webcam over here, and then click on the hold to record button to record some sample frames. And as I do that, I'm going to move my head around to get different angles and so on and so forth. So let's try that now. Cool. So I've got about 43 images of my face there. Now I'm going to do the same thing with the cards class. I click on webcam, and I've got this nice deck of playing cards, as you can see here. So I'm just going to do the same thing and get roughly the same number of images. Otherwise, they'll be biased. So let's do that again. Okay, 39, that's close enough to 43. That's roughly the same number of images. And now I can click on train model. Now, what's going to happen is live in the browser, as I'm talking to you, it's going to retrain the top layers of this model to try and classify the difference between the deck of cards and my face, instead of the things that it already knows about, like cats and dogs and other things. So it's using the knowledge it had from before to then recognize new things. And now you can see in a matter of seconds, it's got a live preview come back, and it gives me my live estimation of what it's seeing right now in the web browser. And it says Jason, which is correct. And if I put my deck of playing cards up, you can see it changes to cards at the bottom here. So Jason, cards, Jason, cards. And you can see how fast that is, right? In under 2 minutes, we've managed to not only create, but also test and prove that it works. And this is great for prototyping. I've seen people use this to combine with Raspberry Pis to recognize if they've left the door open at the house, for example. And if it's left open and it's dark outside, they can automatically close the garage door or something like this. So there's tons of potential here for you to take something simple like this and make it integrated into your own custom products and ideas. So if you like what you've created here, you can click on this export model button, as you see here, and you can then download the resulting model files. And here's the code to then use that, which is you can just copy and paste and put onto glitch.com or something like this. And then you can use this model within your own website and do whatever you like. So it's really up to you to get creative with this and start using it in some interesting way. Now, I said Teachable Machine was very good for prototypes, which it is. But of course, if you've got gigabytes of data, you might want to use something a little bit more robust for large data sets. And for that, we've got Cloud Auto ML. And this is a similar kind of thing, but it runs on the server side and also exports to TensorFlow.js. So you can see here how someone's tried to classify different types of flowers. All they've done is they've uploaded loads of folders of different flower types to Google Cloud Storage, and then they can go ahead and train a machine learning model to then predict different types of flowers for either higher accuracy or faster predictions or some kind of trade-off between the two. So you click on train, you wait a few hours, and then it will come back to you and say, hey, it's ready to download. And you can see here at the bottom right how you can export to TensorFlow.js at the bottom right there. So you might be wondering, well, how hard is it to use this production quality model? And the answer is, it's actually really simple. In fact, so simple, you can fit it on one slide. Let me just walk through this code to explain what's going on here. So at the top, we've got two script tag imports. The first one is the TensorFlow JS library, and the second one is the AutoML library. Pretty standard stuff. The next thing is an image tag. Here is an image of a daisy. This could be anything. It could be an image from the webcam. It could be something else. I've just chosen a random image of a daisy that I want to classify. And then here's the actual JavaScript you need to run. Just 3 lines of code, really. The first one is await tf.automl.load image classification, and you just pass to it the model.json file that you would have downloaded from the previous step in the download options. And we use the await keyword because this is an asynchronous operation. It takes some time for the model to download. So we were telling the system to wait for that to finish before we continue execution of the code. Next, we get a reference to the image we want to classify, in this case, the daisy image above. I'm just getting element by ID daisy. You can see it matches up here. And that I assign to the constant called image. And then finally, all I need to do is call await model.classify and pass it the image to classify, and we'll get our JSON object stored in our predictions object here, which we can then iterate through and print out what we've seen or do something useful with that information. So in just 3 lines of JavaScript, you can actually make a production quality system that is robust and works on the data that you've trained upon. So pretty simple, and I encourage everyone to try this out after the show. It's really fun to use. Then the third way to use TensorFlow.js, of course, is to write your own code. Now, to go into all of that, it would require a separate presentation. And if people are interested, I can put one together. However, today I'm going to focus on the superpowers and performance benefits of running in JavaScript. And first of all, I want to talk to you about how TensorFlow.js is put together. So essentially, we've got 2 APIs. The first one is a high-level API known as the Layers API, and this is very similar to Keras. If you use Keras, you'd actually be very familiar with our Layers API. And below this, we've got our low-level Ops API, which is more mathematical. It allows you to do all the linear algebra and all that kind of fun stuff. So you can see how these come together on my next slide. So we've got our models that are pre-made and easy to use classes. They sit upon the Layers API. The Layers API sits upon the Core or Ops API, whatever you want to call it. And then this understands how to talk to different environments, such as the client side. And by the client side, I mean things like the web browser. Now, these environments then understand how to execute on different backends, such as the CPU, WebGL for graphics card acceleration, and WebAssembly, or WASM for short, for better execution on CPU using lower level instructions. And it will automatically know which environment to use, or you can force it yourself if you know that your model performs better in one of those environments. And we've got the same kind of story for the server side too. You can see here that on the server side, we'd use node.js, and basically we've got the same C bindings as Python does to TF-CPU and TF-GPU, which means you get the same AVX and CUDA support as you do in Python. And as you'll see later on, this basically means performance is the same or even better, as we'll see. Now, the other thing to point out is that if you do prefer to still code in Python for your machine learning, that's completely fine. And you can actually load your saved Keras models via our Layers API, and you can load your saved your TensorFlow saved models via the Ops API. All of this can happen without any kind of conversion process, and it will just run automatically. This is really great if you're trying to integrate with a web team and trying to get more eyes on your machine learning model, because they're probably going to be using Node.js instead for the web infrastructure. So this allows you to integrate better with such teams at very low cost. And then finally, if you want to take a TensorFlow saved model from Python land and execute it in the web browser on the client side, we've got a command line converter you can use that will take the saved model and convert it to the JSON format that we need to run in the web browser. So all of these executions are possible depending how you want to do your machine learning pipeline. So let's talk a little bit about performance as well. So here is TensorFlow.js running in Node on the server side, and you can see that we get the same performance as Python. This is for MobileNet v2, and you can see in Python, it's 7.98 milliseconds, and in TensorFlow.js, it's 8.81 milliseconds to do the inference here. So for all intents and purposes, this is within margin of error, depending what the server was doing at any point in time, and it's basically the same. But what gets really interesting is that if you have a lot of pre and post processing, then you can actually see faster performance in Node.js because of a just-in-time compiler that JavaScript has. And this can be very significant. So you can see here an example by Hugging Face, who are very famous for natural language processing, and they converted their Distilbert model to run in Node. So all they're doing here is they're loading the model in Node, so the inference is actually going to be the same as Python. However, because they converted their pre and post-processing code and logic as well, that's what got the performance boost here. So the end-to-end classification time, not just the inference in the model, actually led to a 2 times performance boost by using Node.js. So that might be something you want to consider, depending if you're trying to squeeze a bit more performance out of your pre and post processing layers. So the other things I want to talk about are kind of the 5 client-side superpowers that you can only get by running on the client side. These are hard or impossible to achieve on server-side environments. The first one is privacy, which we hinted at before. Of course, because everything is running in the web browser, that means none of the sensor data is going to a third-party server. This is really important in today's privacy-conscious world. And of course, if you're doing something with medical applications or legal, or maybe you're trying to support a country in Europe that has GDPR rules, then you need to make sure you're aware of all those privacy situations. With TensorFlow.js, you get that for free if you're running in the web browser. Second point, lower latency. If you're not having to send your data to the server, there's no round trip time to the server and back again. On mobile connections, this could be more than 100 milliseconds before you even get any results. And that really sucks if you're trying to do something real time. So with TensorFlow.js, you can talk directly to the sensor on the device and have a much lower latency. Third point, cost. If you don't have to hire servers with high, big beefy GPUs and RAM and processors that are running 24/7, if you've got a reasonably popular website that's running machine learning, you can save yourself tens of thousands of dollars per month. And then the fourth point is JavaScript from day one has all been about the sharing and display of content and information. And that means JavaScript community is very rich for graphics, charting, all this kind of stuff. And it makes your life very easy to prototype. So there's some really great libraries in the ecosystem that are far more mature for the display of graphics and information. And then the fifth point is reach and scale. Of course, anyone can click a web link and go to a website, and now the machine learning can just work. The same is not true if you're trying to execute this on the server side. First, you have to understand Linux and install a Linux environment. Second, you need to install TensorFlow, which then means you need to install the CUDA drivers from NVIDIA. And then you have to go and clone the GitHub repository, understand the README file, and hopefully, if all of that works, you might just have a chance of executing their machine learning project. With TensorFlow.js in the browser, of course, you just go to a website and it just works. Much simpler if you want other people to try out your project, and that can lead to more virality in the project in that case as well, and get more eyes on your research. And also, the other thing to point out here is that we support 84% of GPUs by running in the web browser. We don't have to run on just NVIDIA GPUs. We can use AMD ones or something else. TensorFlow.js in the browser can run on a MacBook Pro, which I know is very hard to do in other environments. And if we look at the server-side benefits for Node.js, for example, we can see that there are some interesting things over here too. So we can use TensorFlow safe models without conversion. So if you prefer to use Python for your ML needs, that's completely fine, but you can actually then integrate with web teams in an easier way. It allows you to run larger models that you can't maybe execute on client side, or it'd be unfeasible to. If your model is a gigabyte in size, it's probably not the best idea to push that down the pipe to the web browser. It allows you to code in just one language. Currently, 67% of developers use JavaScript as their production language. And if you're already using JavaScript, then it allows you to stay using JavaScript, which is great. It means you have to hire less people potentially, and you have all your code base in one language that makes it easier to maintain. Fourth point, large NPM ecosystem, just like the client-side equivalent, lots of cool libraries to use. And then the fifth point, we already spoke about performance, same performance as TensorFlow Python, but with a just-in-time compiler boost for the pre and post-processing. So I'm going to end here with some resources. Essentially, if there's one slide you want to bookmark today, let it be this one here. Essentially, this has all the links you need to get started and try out all the cool stuff that you've seen on the previous slides. The first link is our website. Lots of really useful information there. We've got all of our models hosted on this link below. And there's many more models than the ones I've shown today. I've shown you just like 3. There's like tens more that you can try out that are just as easy to use and get started with. TensorFlow.js is an open source project, so we're available on GitHub as well. If you want to contribute, we welcome contributions. And if you have more technical questions, we've also got a Google group you can go to. And there's a lot of people starting to ask about reinforcement learning and natural language processing and all these kinds of things too in that Google group. I've also made some CodePen and glitch examples that are some boilerplate code that you can just fork in one click and have a working boilerplate to start from to access things like the webcam that can be used with our models. And it shows you how to do that very easily. And that's a great starting point to start hacking from. I mean, if you want to go much deeper and really go all the way, then the Deep Learning with JavaScript book is really great. If you've got some basic knowledge with JavaScript, that's all you need to get started here. It assumes no prior knowledge of machine learning and will take you from 0 to basically hero over the course of 10 or 12 chapters or so. And of course, there's some other cool courses out there from Lawrence, who's on the chat right now. He's made some cool Coursera courses. Do check them out as well. And some of our GDEs as well have made some nice ones too. Gantler board has made some cool stuff too. So go check out some of the courses online. But if you want a book, then this is the go-to book right now. So the only thing left to say here is come join the community. I've just shown you a few demos today, but there's new ones coming out every single day. And here's just a few more from people all around the world. And I'm particularly proud to say that there's a whole bunch of stuff coming out of India as well. So congratulations on that. It's always so much creativity coming out over there. And if you want to see what's going on in the community, check out the Made with TFJS hashtag on Twitter or LinkedIn. And you can get some inspiration just by looking at that. And if you make anything, of course, do let us know so we can actually share that and maybe even feature you in a future show and tell or something along those lines. So the final thing I want to end with here is, what will you make? I just want to end with one final piece of inspiration here. This guy from Tokyo in Japan, he's actually a dancer by day, but he's managed to use TensorFlow.js to make this really cool hip hop video, as you see here. And the reason I point this out is that machine learning really now is for everybody, not just engineers and researchers, but creatives, artists, and musicians as well. And everyone can really now have a chance to take their first steps with TensorFlow.js and try out machine learning with a very low friction in the web browser and beyond. So do use the hashtag if you make something. And of course, feel free to stay in touch with me on LinkedIn or Twitter. I'm happy to take your questions now. And yeah, please do keep in touch and reach out. Thank you very much for listening. Oops, there we go. Yeah.
Thank you so much for that amazing session. It was really awesome.
Cool.
We will take some questions. Just let me put it.
And of course, if you have questions later, I can take them on social media as well if needed. So no rush.
Yeah. Also, many people were asking about that yellow thing, like beside your hand, which is blinking.
So yeah, I just got a new toy. This little friend here is called the Clickbot. He is a robot, and you can program him and do fun things. So my aim is to hack him to use some kind of machine learning at some point. I'll see how far I get with that. But he's completely modular. You can take him apart and do whatever you like. So it's
that's
cool. Yeah.
Okay. The first question we have is from Sahil. And
Yeah.
the question is, what level of expertise do you need on JS for TFJS?
Yeah, so you just need a basic knowledge of the language syntax. As long as you're comfortable with like conditional statements, variables, functions, objects, that kind of stuff, the bread and butter for any programming language, then you can get started with TensorFlow.js very easily. I mean, even without any programming, you can use things like Teachable Machine just to try it out and see the results. But if you want to start hacking to turn it into your own creative idea, then you will need some programming knowledge, of course. There's plenty of great tutorials online for learning JavaScript if you're new to JavaScript itself. Code Academy, things like this are great resources for that too. So yeah, just kind of learn the basics and then go have a play with some of the glitch examples I put up there, for example, which is basically gives you the boilerplate you need to get started. You can just start tweaking the variables and things and do things as you please.
That's awesome. Okay, the next question is from Kevlin, I guess. Any tips, practices, or conversation to follow when preparing TFGS model for production environments?
I think it's the same as any machine learning system, no matter what language you're using. Essentially, you need to make sure that you've got enough training data that's not biased and all this kind of stuff. So make sure you've got enough, that if you're trying to recognize objects, you need to have objects of all the different situations that object can be in. So if you're trying to recognize cats, you need to have different breeds of cats, different stages of the life cycles, different colors, indoors, outdoors, all taken at different angles and different rotations and lighting conditions in order for the machine learning to have the best chance of learning what a cat pixel is, right? So same advice applies to any form of TensorFlow, and I'd follow the best practices for any language there. Yeah.
That's awesome. I did try teachable machines, and I made a small model which can detect mask and undetect mask. So that was a good experience for me.
That's cool.
Okay.
Yeah.
Thank you so much for sharing your insights about TFJS, and we really look forward to interact with you in the near future.
Awesome.
Thank you, everyone.
Thank you. Thanks for listening, everyone. Cheers. Bye-bye.
Okay. So next in we have TensorFlow project showcase. So you might have seen we have displayed entries for TFUG India Summit project showcase, and today we have Navendu from one of the person selected for displaying this project. So I'll without further ado, I will invite him to share his screen and take over.
Hi guys, thanks for having me in this session, and I hope I will be able to follow up after all these amazing sessions. So I'm here to talk about my project, which is a NSFW filter, which is a browser extension to filter out NSFW images using AI. And yeah, I will just show the demo, and you can see how it works. So as you can see, the NSFW images are blocked by our extension, and like it is hidden from the user. So yeah, and as you can see, it is really fast, and it works really fast. And yeah, in the next one, you can see it performing on a normal image of some cats. And as you can see, there is a small microsecond delay in which the deep learning model will analyze the image and detect if it is not safe for work or not. Okay. Yeah, so how does it work? So we use TensorFlow JS, and by now you have been familiar with TensorFlow JS from Jason's previous sessions. So what we do is we have trained the TensorFlow JS model to detect NSFW images or inappropriate content. And when a user loads a web page, it will actually hide all the images. And after hiding all the images, our model will check if the images are NSFW or not. And if they are NSFW, they remain hidden, and regular images are made visible back to the user. Okay, so the core component of our project is the TensorFlow JS model. So we trained the model on 60+ GB of data. And this model is based on MobileNet model, and in the test data, we got 93% accuracy. So it has been trained to detect these 4 classes, and as you can see. And this is the results of our model. And we have some pretty good results, but it is not perfect, but it works really well. And this is the basic workflow for how all things are put together in a project. So first, when a user loads a web page, the extension hides all the images from the user, and these images are then passed to the TensorFlow JS model, and this model will check if the image is not safe for work or not, and if it is if it is not inappropriate or not NSFW, these images are made visible, and if they are NSFW, they remain hidden from the user. So that's how we hide the content from from the user. And we like to share that our project was featured in Product Hunt, and it is also it is now readily available on the Chrome Web Store and Mozilla Firefox add-on store, and it is completely open source and free, and you can check it out in GitHub and in Product Hunt, and you can download it and install it on your devices from the official Google Chrome and Firefox stores. And yeah, I think the team will share the links to my project, and this would not have happened without the support from our team. And we currently have 10 contributors who are working on this project, and they have taken this project to really great heights, and it has become really really great to work with all these people. And yes, to conclude here, we are completely open source and we are completely free. So if you would like to support our project, you can do this by becoming a patron or sharing a small donation in OpenCultive. If you have any doubts or if you need to know more, you can reach out to me at my Twitter handle. It's in the bottom, and you can ping me in LinkedIn, and I would be happy to clear any doubts. And I would like to thank the team once again for allowing me to present in this TFUG India Summit. So thank you.
Hello, folks. I'm back again, and thank you, Ravindu, for sharing your project with us. It's amazing, and it got to nail out this kind of projects and being able to present at such a huge platform, I believe. And I honestly think that we were able to provide you with a platform that would complement your project. So we do really
Thanks
hope.
for that.
So yeah, that's about it. Not for TFUG India Summit in totality, but that's it for day one. Today we had, of course, an amazing line of speakers who talked about TensorFlow core APIs and also kind of gave us pretty great insights about TensorFlow's offerings for the web, that is TensorFlow JS mainly. So with that, I really want to thank you folks for supporting us, for joining us, and for staying till the end of day one. Tomorrow we'll be back again with another amazing lineup of speakers. Tomorrow we'll be covering TensorFlow for mobile. So all the Android folks out there and the folks that are looking for optimizing their models for production purposes, you cannot miss this one, right? You cannot just miss this one. So with that, thank you all once again, and we will see you folks tomorrow. Bye.